guys, sorry, we'll be starting in like maybe 1 or 2 minutes. Sorry for the delay. Free to keep talking for now.
Hello. So, hi everyone, welcome to AI Squared. For the opening of AI Squared, we are so happy to have you here. We just quickly go over all the main details about the tournament and everything you need to go to get started. First thing, the agenda. So, we're just going to have the land acknowledgement, some information about UTMIST, about AI Squared. We have a keynote from someone from AI Warehouse, so that and some more details. So, in terms of the land acknowledgement, let's acknowledge the following. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron, Wendat, the Seneca, and the Mississauga of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So, first of all, what is UTMIST? UTMIST is the largest AI and ML club at U of T. We have over 200 plus developers in various teams, 300 plus internal members, 80 plus executives, 20 plus design teams, and 5 flagship events. Our goal is to empower students of all skill levels to grow their professional and academic careers in ML and AI. How do we do that? We do that by building valuable workshops, content, and opportunities. We have various conferences, hackathons, and initiatives lined up for the year for students to explore this growing field of AI and ML, and which is why I think you guys are here as well. In terms of initiatives and events, we have AI that some of you might have been a part of, AI Square, you're here right now. We have DEF CON in January, where most of our projects will showcase what they've been working on, and there'll be some companies. We have GenAI Genesis Hackathon, which is Canada's largest AI hackathon. And then we have QCAI, which is Canada's largest AI conference, which is hosted along with Queens and Waterloo as well. In terms of initiatives we undergo right now, we have the ML Fundamentals program, which is a program for beginners to come and explore ML and lay their hands without any prior experience. Academic workshops where you can learn things like reinforcement learning, computer vision, AI interpretability, and these will be running throughout the year. The reinforcement learning workshop just ended like a week back. And the last thing is industry projects. We collaborate with a lot of different companies and help them develop their platforms. So we'll have some more projects opening up in the winter as well, and we have some running right now. This is our link tree, so feel free to join our Discord, Instagram, or any other platforms to be updated about what's happening. And I'll let Jessica take it from here.
Thank you, Tanay, for that amazing introduction about UTMIST. For those of you who don't know, he did not introduce himself. He is the co-president of UTMIST. So let's give a round of applause for him, and also Stephanie at the back who's supporting us through this event. Yeah, I guess welcome everyone to AI Squared. My name is Jessica. I am co-VP academics this year, alongside Caden, who will be here later. Yeah, I guess we'll just get started with what is AI Squared. So, as you guys might have seen on the website or through any of our marketing, essentially AI Squared is we built this 1v1 platform fighting game, and you guys get to code the agents to battle each other on it. So, what you get to do in this event, you get to explore AI in games. Because who doesn't like video games, let's be honest. We're probably all computer science and engineering students, or majority of us, and I personally love a good video game. You get to train an agent, you get to have hands-on experience in machine learning and such, and you also get to battle other opponents to see who makes it to the end of our tournament bracket, of our finals tournament bracket, which is going to be on November 2nd in My Hall 150. So if you guys are here for that, yeah, please go check it out. We'll also have a bunch of speakers coming in today and also on November 2nd for you guys to see. Yeah, and we have a quick reveal of our prizes if you saw this on our Instagram page. So first place prize in this tournament is going to get a HyperX Cloud 2 headset. The second place prize is going to get a Royal Clutch RK75 mechanical keyboard. Third place, Logitech G502 gaming mouse, and our fourth place prize is going to get some Steam gift cards. So if you guys are excited, I hope you guys are excited for these prizes and to have a good week of hacking. Yeah, so we also have one more sponsored prize from Tenstorrent, who are going to be giving out Black Hole P150 prizes, which is kind of like a APU in a sense. It's like compute for you. So more information about this prize will be shown later. Yeah, and we actually also have a speaker from Tenstorrent coming in later to show you guys how to build neural networks using their library. So I kind of wanted to go into this a little bit and have a little bit of audience interaction. AI Squared, to give a little bit of background, it started off as a project from our previous co-president, Andrew, who some of you might know. And he really wanted to build this AI game, and then he turned into a UTMIST tournament. And here we are trying to put this on for a broader community. So I just kind of wanted to ask people in the audience who are here right now, why did you guys want to, what made you guys want to attend AI Squared? Yeah? You wanted to make a non-AI thing to see if you can beat other people. That is a really awesome idea, because one thing about our game is that it is it's supportive of non-machine learning types of algorithms as well. So even if you wanted to do if statements, that could also work. If you want to go really beginner level there. And don't worry, we will have a workshop or a code-based walkthrough later in the day to get you guys started. I guess does anybody else also want to answer that question? Okay, well, I guess personally, AI Squared was a really fun project to kind of help on. There's a lot of AI in games that is happening around the world, but at University of Toronto specifically, it it is something that is not really prevalent, and we wanted to bring kind of like attention to that and like how you can apply machine learning in different areas, in different fields. And like gaming is a really big opportunity, and like across Canada, there's a lot of hubs in like Montreal, a lot of research going on. There's some in Vancouver as well. And even here at University of Toronto, we have a lot of like research in games that you might not know about. So like say, there's a couple of research presentations that we might be having later, which will kind of discuss this. So I guess like without further ado, let's just get some more logistics out of the way. Hacker package is over here. If you guys haven't scanned the QR code, this is also posted in our Discord announcements. Yeah, so if you guys want to scan the QR code, this will have the schedule and a lot of like other details about the events, detail about our speakers who are coming. Yeah, so I'll give you guys a second to scan that. And now we also have a couple of other things. So first of all, we have an open source GitHub repository, which which has like our game environment and also some documentation on on guides on how to submit, how to validate your agent, and how to also like just clone the repo, how to get started with that. Also, please make sure to join our Discord server. That's where that's gonna be where all of our announcements are gonna be posted, and also like where you can reach out to mentors, where you can reach out to any of the UTMIST team as well, to see like, or just chat with other participants as well. Yeah, so if you're not already in the Discord, please do so. All right, I'm going to move on to some of our sponsors now. So as mentioned earlier, we have the sponsored prize from Tenstorrent. They're also one of our platinum sponsors. So a huge thank you to Tenstorrent. They're providing a lot of the compute for UTMIST, including this tournament. And also, we're going to have a workshop from Ambrose Ling, who is a machine learning engineer intern currently at Tenstorrent. And he's going to be talking about deploying neural networks on Tenstorrent hardware. So you're going to get a brief overview of like how Tenstorrent hardware architecture works and how you can use the software stack of with TTN and TT Metal to build your agent and build and enter for the prize category. And next we have a gold sponsor, Artificial Agency. So Artificial Agency is an AI startup from, they're based in Edmonton, but they honestly are like one of like the growing, I guess like AI gaming companies in Canada. And they do a lot of like AI behavior, game engines projects. So, and we're going to have a workshop from Russell, who is a strategic growth and developer relations. He's on that team for Artificial Agency. And it's going to be an AMA, so Ask Me Anything with Russ, and the topic is going to be how the gaming industry is shifting to agents. So you'll get to interact and discover how AI agents are transforming the future direction of the gaming industry. And yeah, Russell has a lot of experience in the gaming industry, having worked at Unity and also in World AI. So this is going to be a really valuable talk at 1:30. And next we have this quick keynote from Tyler Smith. He's a software engineer at AI Warehouse, and they do a lot of, if you search them up on YouTube, they do a lot of cool reinforcement learning projects with Unity and games in general. So he isn't here today, unfortunately, but he did prepare this really awesome video. So I'll let the video introduce itself. And yeah, here we go.
Hello from Texas, everyone. I want to sincerely thank you for joining me at my talk today. My name is Tyler Smith. I'm a software engineer at AI Warehouse, and I've been programming and making games for just over 10 years. Growing up, I had a lot of interest in AI, but back then I had no idea what reinforcement learning or latent diffusion was. I started coding in Gary's mod of all things, and then kept up game development whenever I learned about the Unity engine. But of course, I still had a problem. I needed to make money. So if you can think of any retail job, the chances are pretty good that I've done it. I've been a pool boy, I've been a flooring contractor, supervisor of a Whole Foods, manager of a car wash. I was a pool boy again at some point. I even worked at Little Caesars for a while too, which was just absolutely crazy. It can't be put into words. And after a lot of retail, I landed a position as a lead software engineer and Salesforce developer for a law firm here in Austin, Texas. I did a lot of full stack web development, and I even had to use WordPress. Ugh. And so fishy, it's because it was. And I'll get to that in just a minute on how that was even possible. There's a whole novel's worth of chicanery that I'm going to have to summarize at the end of this, so just keep paying attention. I'll get to it. It's a very interesting story. But let's fast forward to now. I'm currently a full-time employee at AI Warehouse, where we're training AI to do really, really cool and fun things. This is my dream job, and it's been a lot of work to get here, but I'm very happy. And I want to share with you some of my tips that I use to get to where I'm at now in my career. And you might have noticed that before AI Warehouse, I never had any formal education, training, or professional work in the machine learning field. And I want to make it clear that this talk is not for you to land jobs that you're otherwise not qualified for. This is instead a way that I want you to start thinking about jobs that you feel like you're not qualified for, but on paper and in reality, you are. I want you to be able to take these skills out and use them in the real world, and land jobs or make connections that you previously thought weren't going to be possible. I want this to be tools that you can use to open doors. And we might also spend 6-7 minutes at the end talking about things to watch out for in employers, good signs, and red flags. So outside of the circumstances that we find ourselves in our daily lives, I believe that there's a certain type of opportunity luck that plays a huge role in networking and getting jobs. And I really believe that this opportunity luck, or this like opportunity chance, like the chance that there's a great opportunity that will present itself to you and there will be a moment where you can try to seize it. I believe that luck chance can actually be increased. And there are a few ways to do this, but I want to highlight what's really worked for me in the past. So I distilled and compressed all of my professional experience and job hunting prowess down into an acronym for you: SAD Bagel. Each one of these letters is going to stand for something that you can spend some time looking into and trying to improve. Let's get into it. Showcase. I think for most of you who are already looking to make more connections in your career, or maybe you have a LinkedIn and you're job hunting, your showcase or your portfolio is already a focus. But I want to reinforce that as we eat the rest of this sad, depressed bagel, keep in mind that your showcase is a supplement that you can use to build your credibility. And an even better way to do this is to make a YouTube channel or some sort of social media where you can show off your knowledge and your experience, anything that can get people looking you up and getting excited. And that's the second word for this. I'm really sorry, guys. I tried to make the acronym work, but it was so hard to find good words that start with A. D. Distinguish. Try and make your portfolio a little weird. Just try it. Try to get some feedback on it and go for a few applications. Show it to family and friends. Let me give you an example. I went to a job fair once and I looked up all of the companies attending beforehand. I took the logos off of each website of the company and I printed it out on a different version of my resume with their logo at the top next to my name. If you look up any resume guides or any help with like job hunting or job fairs, nobody's going to tell you to do this. They might even suggest against it. But I got 2 calls back and another connection with an owner of a small company, and they all mentioned that having their logo there impressed them in some way. So really take every opportunity, no matter how small it is, to stand out. On your resumes, try making the fonts and the backgrounds a different non-standard color. Put the company logos on it, make it fun. And that's just for resumes. When you go to interviews, if it's in person, make sure you have a great, solid handshake. And that might sound kind of outdated, like, oh, we need to have a strong handshake to show that we are a capable person in the workforce. But I actually think that it's still important that sometimes the person you're trying to impress is going to be expecting that. And even if it's not important for that interview, it's going to be the cumulative effect of all of these small things adding up. Keep that in mind for the rest of the talk. That's going to be a recurring theme. These small things really do matter when you put them all together. So as an example, if you are going to a panel interview, I would do all the points that I just covered, like all of the prep. Make sure that you are dressing your best appropriately for the situation. Your hygiene is good. And whenever you go into the panel interview, I would even go a step further and handshake everybody, walk around the table and introduce yourself to each person individually. Like look them in the eyes, give them a handshake and say, hey, my name's Tyler, super nice to meet you. Hey, my name's Tyler, super nice to meet you. They'll be like, wow, this person really just like took a minute and a half to walk around this whole table and like shake all of our hands. That's it's uncommon, but I really like seeing that in someone who's interviewing with us. It might sound weird, but it really works. Compare that scenario to the scenario where the person walks in and they wave hi to everybody. They say, hello, my name's Tyler, and then they sit down and they're ready to begin the interview. The impact between those two situations is very different. Sometimes these small things sounds like they're not really as important as your skills on paper, and I can understand the argument that the skills on paper are the most important thing in interviews, but remember that you're selling the idea of how great it's going to be to work with you, specifically you. So what I'm saying here is that you want to stand out in a positive way. When the interviewer or rep or whoever from the job fair thinks about that stack of resumes, you want your work to be one of the first things to come to mind. And of course, with all things, moderation is key. So use some discretion. Don't make your resume super hard to read. Don't put a background on your resume if you're going to have to print it because it's hard to print. Don't wear your Mr. Antenna cosplay to the job fair, and don't wear a suit if you have an engineering interview. I learned that the hard way. The first time I had a software engineering interview ever, I wore a full suit and tie, and I got absolutely roasted for it. Okay, so this marks the 8-minute hydration reminder. Drink your waters now, and as an aside, I so happen to have a funny story. So I always have a water bottle with me during interviews. It really helps to just take a sip when there's some silence or after you're done speaking or just to hold on to something. But during my first remote panel interview, I was on camera and took a sip of water, and he asked me a question at the same exact time. So I tried to swallow it really quickly, but it ended up going down the wrong pipe. And I started doing that thing where I was like half coughing, half choking for like a minute and a half. And I just tried to use pure willpower to not choke on the water, but I did, and I made a fool out of myself. So I spit the water all over my webcam during the panel interview. And, initially I think the reaction to that is, oh my God, I'm so sorry. Are you okay? But now that I look back on it, I actually think that it did set me apart in a good way, even though the experience was awful. What people are looking for is human beings. People are looking for other human beings to make a connection with and to have at their company so that they can work with them. They're not looking for robots or AI to replace people. I understand that like some people might and CEOs might for better profit margins, but when we're talking at a human level, there is a desire to connect to other humans, and that's what people want. B, easy to work with. So the whole point of this section is to convey the idea of being as frictionless as possible by putting in a little bit of extra effort proactively. Let's say we have two applicants that we're considering, Keith and Elliot. Keith is very skillful for the job. He is great on paper, and he's got a good enough personality, but you notice that he always clocks in a little bit late. He's a little bit late to the meetings, and he's usually unprepared. You have to ask him for things. Even during the interview process, he was a little unprepared and he forgot some materials, which is, not a huge deal. He's good on paper. He's good at the job that he does. They're just these small things. But let's say also we have Elliot, who's just as skillful in every single way. The only difference is Elliot is always prepared and has like their materials, their papers, their documents ready to go. They turn in their work early without being asked, and they start to solve and proactively think about problems before you even realize that they're an issue. If I was between these two applicants and they were both equally skillful, I might as well go for Elliot. There's no reason to pick Keith over Elliot because Elliot is going to be proactively handling these things. So what actionable steps can we take to improve upon this? Because it's great to think about this kind of stuff, but unless we know what we're doing, it's not really all that helpful. So there are two things that are going to be helpful in this regard, and I think that as you do them more, you will learn a sense of when they should be done and when is too much. But I think that inconveniencing yourself by like 5% can really help you prepare ahead of time and exceed expectations. If you have something that you are on the fence about, just go ahead and do it. If it takes 2 or 3 minutes, just go ahead and do it. It is going to make a huge difference in the long run. Secondly is being easy to collaborate with, easy to talk to, and being reliable. Just remember, if someone has one open position with 2 candidates who are at an equal skill level, they're going to go with the person that is more reliable and easier to work with. Okay, so that brings us to the next section, A. This is the most important section. Pay attention. If you don't take anything else away from this whole talk, take this part away and it will help you, I promise. A. ABCs. Always be communicating. I'm so sorry about the acronyms. It was like a whole thing that I just kind of stuck with and I thought it was going to work out, and it didn't. But if you kind of look at the A, it looks like a cell tower, so maybe that's a good way to remember. Okay, so we've all heard the phrase, communication is key. Well, that's right, and I'm here to tell you that it's not just a key, it is the key. Like in this little graphic, they need this key to go. The key of communication is everything. This is going to be the life and death difference between if your interviews go well, if your talks are going well, if this talk is going well. Mastering communication is going to be so helpful for you, not even just in your career, but like also in your personal life. Communication can help you in every single aspect. There's so many returns from practicing the skill. I don't know if this is common knowledge, but CEOs will pay hundreds of dollars an hour for consultants to come in and tell them how to talk to people. There's a reason why company owners will take improv lessons. That ability to improvise on the spot is invaluable. And those two things are actually related. CEOs will pay professionals to come in and teach improv to their leaders because it's so helpful. So this is what I want you to do. If you're serious about wanting to be a better communicator and you want to leverage as many skills as possible to open up doors for you, then I want you to take some time when you get home and actually work on improving your communication skills. Look up these resources on YouTube. I'm going to have a playlist that I put at the end of this on the last slide. All of these things you can actually practice. Whenever you go to a coffee shop, there are skills here that you can practice. From these videos, you can actually put them into action. And for all of my gamers out there, if you play games online, this is going to sound really nerdy, but you can actually use some of these skills and practice them online in voice chat. Like that is a real thing that actually works. And I'm not saying that you should log on to League or COD and start using voice chat to try to better yourself. I don't think that you're going to get anything helpful out of that. But you could actually use these opportunities to try to bolster yourself. You could try being a better listener while other people are talking. And for all of my extremely anxious folk out there, I feel you. This is a great chance to try new skills that you're learning in a little bit of a safer environment than doing it in front of a lot of people. I will note, though, that there is a bit of a caveat to this. You're not going to be getting the face-to-face interaction that you would be getting normally, so just take that into consideration, because there are just a lot of social cues that you can't pick up over voice chat. But if you are a gamer and you end up spending a lot of time online anyways, this is a great skill and you should use this. This is an amazing opportunity to practice your communication. You're going to be talking to people anyway. Okay, so we've covered learning from great speakers, how to put those skills in action, what it's like to do that online if you have the ability to. But there is one more thing that is so much harder than the rest and of anything else that I've asked of you. But this one thing will actually change everything. It will have the biggest returns, I promise you. sound like one of those ads right now. I feel like I'm about to sell you something every time I record this part. Sign up for an improv class. Do it. There are free improv classes. There are paid improv classes. But some of the best speakers that you know use improv. Streamers use improv. Motivational speakers use improv. CEOs use improv. People that are leaders use improv because it's so helpful for improvising on the spot, but also getting comfortable talking to people, getting comfortable trying new skills and doing different things, and extending outside of your comfort zone a little bit during normal conversation. G, get good at explaining. So let's say that you're going to put a new project on your portfolio where you created a Unity environment that trains 1,000 agents and you're using ECS architecture. You better be able to explain how you did that to me. Even better than that, you better be able to explain it to someone who's never been in the field and doesn't understand anything about computers. And even better than that, you better be able to explain it to a 5-year-old who has no idea how to spell Unity ML agents. I have no idea. I've never met a 5-year-old. I don't know if they can do that. There's no worse feeling than understanding how something works but failing to articulate it to someone, especially someone you're trying to impress. At best, you will come off as stupid. At worst, you will come off like you're lying about your qualifications. And of course, the way to get better at this and to make it perfect is practice. So get a list of the topics that you want to go over, practice explaining those to someone with less understanding of you in that subject. Try talking to friends and family or someone online. You can even record yourself in the mirror talking to yourself. That's very, very helpful. And here's the last thing to keep in mind when you're practicing explaining. Experts keep it concise. If you are explaining something, the best way to show fundamental knowledge is to explain it to all those groups of people that I said before, but in a concise manner that shows your foundational knowledge of that subject. And just keep practicing. Practice over and over and over. You will get better at it. Okay, that's enough practicing communication. Let's move on to something that is actionable. Email everyone. This is the tip that I get, is someone asking for bug reports online. Email them and try to hit it off with them. Make a connection. If there is a job posting you're interested in, but you feel like you don't really have the skills, email them and let them know you're interested. There might be something adjacent to that position that really works out for you. There's a job posting from a popular machine learning YouTuber, but there's no way someone so popular would pick little old you. I think you can see what I'm getting at. So there was a app that I was using a while ago, actually, that was like a AI product summarization tool. And it was supposed to like help you find some of the best products that you could buy using AI to summarize their descriptions and reviews. And the guy was looking for bug reports. So I ended up emailing him and sending some stuff to him. And we actually started to hit it off, and we started talking about the state of AI and different cool projects that we're working on. And now we have an open communication. And that might not seem like a lot, but if you can imagine now, at any point I could reach back out to him and say, hey man, I don't know if you remember me, but a while ago we were talking about AI. We really hit it off. I saw another job posting that you had on your website, and I was wondering if you wanted to grab a cup of coffee and talk about it. That's really powerful. Those connections really add up over time, and having those connections just will open a ton of doors for you. Even if you're not hitting people up to ask about their job postings, having connections is helpful. It builds that network of people that you can rely on or reach out to. Before I started doing remote work, I was printing off my resume with my email bolded at the top of it. And I would walk around to so many businesses and just hand out my resume to them, trying to get a connection going. And I think the key here, the thing that's really important to remember, is that at the other end of every email that you send, there is another human being that's waiting to make a connection. Whether they realize it or not, someone is on the other end wanting to make the same connections that you are for the same reasons. If you can use this in synergy with improving your communication, those two things are going to open so many doors for you. Oh, and also always send follow-up emails. Always. After you're done with a interview or you're done meeting somebody, always, 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 always send a follow-up email just explaining that you had a great time and you're looking forward to seeing them again. And, you know, it's okay to send follow-up emails even after a week. Just don't send so many that you are appearing a little overeager. Okay, we're reaching the end of the sad bagel. L. Learn to say, nah. So this one was actually surprisingly hard for me to learn and to start using effectively. This one is paramount, though. I don't think that there's any way that you can get around this one, and if you don't follow this, then you're kind of shooting yourself in the foot. So let's say that there's someone in the field that is like, hey, we're really excited to bring you on the team. Have you worked with this technology XYZ before? It's been around for like 6-7 years, but we're finally integrating it into our actual stack, and we want to know if we can find somebody that's using it. If you don't know this like the back of your hand, or at least are very familiar with it, don't say yes. Don't say, yes, I know this technology. That is just going to lead you down a bad path. There's almost no quicker way to set yourself up for failure. And this is surprisingly hard for some people to do, myself included. So I really think that, like everything else on here, it's just practice, practice, practice. Just keep training this skill and it will get better. You're trying to get to the point where someone can ask you if you know a skill and you can comfortably say no, but I would love to learn more about it. That's really, really important in interviews. A lot of people are looking for that honesty over you just knowing the skill. It's really just a real question. They're just curious if you know the skill. It's not a bad thing that you don't. And as another example, if someone says, hey, I'm really excited to have you on the team. We have this skill Z here, but I noticed on your resume you don't have it. Have you ever worked with that? It would be so great for you to respond with, no, I actually haven't seen that, but I did see that on the requirements, the prerequisites for the job posting. So I spent a good 30 minutes before the interview just brushing up on it. I wanted to learn more about it, and it looks really cool. So I was actually really curious, and I wanted to hear what your thoughts are about it because I'd love to learn about it some more. That will get you so far. That's going to do great for you. I guarantee you your interviewer will be more impressed with that question than if you said, yes, I know this thing, and then you just have to flounder for the rest of the interview trying to figure out what it is. Okay, so we're getting close to the end here, and I've been rambling a lot, so we're going to have to speed run these last two sections. So if you remember earlier in the talk, near the beginning, I said that I had got a job as a lead software engineer for my first ever professional role in the industry. Predatory companies and red flags to watch out for. I'm going to go over some red flags to keep an eye out for. You need to do some more research into them yourself, and if you are dealing with one of these, you should talk to somebody about it before you make any rash decisions. Okay, first, delay in promises. If your company is promising you a raise or a bonus or a yearly review and you never see anything come out of that, but the promises keep coming and they just say like, okay, yeah, we'll do your review next week or next month. That is a big red flag. You need to talk to somebody about it or leave if you can afford to. Results-oriented hours. This one is a big lie. Basically, what results-oriented hours means is that they are expecting you to just get the work done. It doesn't matter if you need to work, only 20 hours a week, or if it ends up being a 55-hour week. Newsflash, it's always going to be a 55-hour week because there's always more work to do. Results-oriented hours is something that's honestly a little too prevalent in our industry. So I personally think that it's a red flag. It might be different for where you're working right now. But just keep an eye out for that because you might end up working a 996 before you realize it. And if any company is boasting a 996 like it's a great thing to do to work from 9 a.m. to 9 p.m. 6 days a week, They are trying to get as much work out of you as possible. They don't care about you. Okay, third on our list of scary things is either high turnover or the owner talks bad about previous staff. Owner or boss, it doesn't matter. If you notice that a lot of people are leaving, start reaching out to people, asking why. What was it about this job that was so bad? What was it that was good? Try to get some more information. But if you notice that your boss is talking poorly about people who were here before, there is a good chance that the issue was not with the people, but with the management itself. So just keep an eye out for that. This is more personal experience than the other ones, so take that with a grain of salt. This one is very sad. Unpaid work. Never do unpaid work. The reason that you are working is so that way you can get paid. You may also love your job, but would you be doing it for free? If you're ever working for free, and that includes a week of onboarding where you're not getting paid, or there is a delay in payments and they're not going to be able to pay you for a week or 2 weeks, and you're getting your paychecks late, any of those are signs that there is something seriously wrong with the company or they are taking advantage of you. I know that as you are breaking into the field, it can feel like a very desperate search to find a job and sometimes settle for things that aren't ideal. But any of these red flags, and especially if they're combined with other red flags, can result in just some really, really bad and awful working conditions to be in. You have rights as an employee. There are expectations that are reasonable and okay for you to have from your employer. Keep these things in mind. Okay, so this isn't really as relevant as the rest of my talk has been, but if you have ADHD, or if you have a direct report that struggles with ADHD, and they struggle with getting things turned in on time or having trouble prioritizing tasks, I think that the best way to approach that is to have an open conversation with what are the things that are difficult to do and what things can make it a little bit easier. With some accommodations, it does not mean that you are a worse employee or that your employer would even see you that way. It just means that we can do our work a little bit differently than we would be doing it normally, and we'll be just as efficient or even more efficient than we would have been. So I'm going to leave you with a book also. This is Succeeding with Adult ADHD by Abigail Livrini, PhD. It was really helpful for me in terms of prioritizing things and how to reach deadlines. There's a lot of that kind of talk in here. It's not sponsored. I wish it was. Dr. Livrini, hit me up. So, the grand closing ceremony. I want to sincerely thank you for taking a gamble on my talk. Good luck with the tournament. I'm really excited to see everything that everyone makes. I'm in the AI Squared Discord server, so ping me if you have cool stuff. I would love to see it. And of course, I literally could not have done this without Andrew and the help of the UTMIST team. Let's give them a round of applause, everybody. All right. I can't actually see you guys, so I don't know if you're clapping, but I'm imagining like all hell is breaking loose. You guys are going crazy. Okay, so goodbye, everybody. I'm going to leave you with this slide here. On the left side is a QR code for the AI Warehouse Discord. This is not the AI Squared Discord where the tournament's taking place. This is the official AI Warehouse YouTube channel Discord. And if you turn your attention to the right side, we have a playlist that I made for this talk. I'm going to keep updating it and adding new videos. It's basically just a huge conglomeration of all the videos that I think are helpful for improving your communication and just some like general tech tips and useful things that I enjoy watching. All right then. Thanks again, everybody, and good luck in the tournament. Bye.
All right, so yeah, Tyler, yeah, he's a really great guy at AI Warehouse, like works on a lot of like their videos and such. So if you do have a chance, I do highly recommend like checking out one of their videos. And you might notice a theme where it's like they have little cubes. Our game, if you already checked it out, is also little cubes. Like we did this in partnership like with them last year, and yeah, really grateful to have their support on all of our projects. So. really interesting. That's where I do a lot of my research in actually. So yeah, we'll be having Jingmin here. And yeah, we're gonna go for a quick break. And yeah, we'll be back. Thank you, everyone.
the satellites are down, yeah, they're all down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down? Pixelated kisses got me going insane. Replicate this moment from a million miles away. Waiting for the signal, baby, never make a sound. If we never hear from me, all the satellites are down, yeah, they're all down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down?
Yeah, I don't know. I think I should I'll just let Jingmin introduce himself. Yeah.
Hello, everyone. Oh, thank you. Glad to see you all on this reading week. Thank you for spending your time here. I'm Jingmin. I've done some R research in the past. And yeah, this competition is probably very centered around reinforcement. How many of you have heard of that before? Or like studied it, like know what it's about? Okay, some of you. Who went to my R workshop series? Perfect. Okay, give them extra credit for the. No? Okay, but yeah, so RL is a big part of RL is a big part of this competition, and it's okay if you don't have any. It's okay if you don't have any like experience in it. This is why we have this workshop. But yeah, hopefully this will give you some ideas, some inspiration to create something good. And yeah, we just want you to learn, right? At the end of the day, we're all here to learn. So let's just get started. Okay, so let's talk about reinforcement learning. Yeah, let me just quickly give an overview. So I'm sure a lot of you, if you have taken an AI course at U of T or whatever university you're from, you've probably seen this diagram, right? Your professor will say, okay, so you have machine learning, and then you have like three branches of machine learning, right? You have supervised learning, unsupervised learning, and reinforcement learning, okay? And in the course, they'll probably go over supervised learning and unsupervised learning, but they'll say, okay, let's leave reinforcement learning for a later course, or whatever it is. And at least at U of T, that's a lie, right? They don't really talk about ring. There's not really an RL course at U of T, not to my knowledge. So yeah, it might be an esoteric field to many of you, but hopefully this session will help clear it up. But yeah, so RL is one of the three big, quote-unquote, branches of machine learning. Now, examples of reinforcement learning. I believe you guys just got a talk from AI Warehouse, Tyler, and you can see that this is one of his tasks, right? One of their things they did, which is AI learns to escape, right? They train some AI agent to escape some room, for instance. Other examples of reinforcement learning, DeepSeek. I mean, I'm sure you guys used DeepSeek before, ChatGPT or something, and you might think, okay, well, but that's actually a large language model. But I want to tell you that actually it's trained, partially at least, with reinforcement learning. So yeah, it's in one of the most ubiquitous AI things, around. And finally, I bet you guys have heard of AlphaGo, the agent that can beat like the top ranked Go player in Go. So yeah, these are all trained with reinforcement learning, and these are very sort of, they're pretty hard tasks, right? So just goes to show the power of RL and hopefully motivate you guys to delve deeper into it. So just get into it, right? What is reinforcement learning? So reinforcement learning is when an agent interacts over time with its environment in order to achieve a goal. Very simple. That goal could be, reaching a literal goal. It could be, defeating your other player. But there's a goal, and you have some decision-making entity, we call that an agent, that interacts most of the time with some environment and receives signals from the environment to better understand how to achieve that goal. So the agent should do the following, right? Be able to sense the state of the environment and have clear goals relating to the state, right? At the end of the day, you want the environment to inform how to best reach this goal. And most oftentimes, goal will be to maximize a quantity called the return, and we'll discuss this later. Okay, by the way, if you have any questions, feel free to raise your hand and I'll answer them. So what is not reinforcement learning? Okay, and this was a misconception when a lot of people first start. Reinforcement learning is not like a model architecture or like a single algorithm, right? We're not going to talk about a specific configuration of weights. You know, I'm not going to introduce a new variant of the LLM, right? It's more of a, a way of framing problems. It's a new sort of way of thinking paradigm, right? It's different from supervised and unsupervised learning. So if you come here expecting I'll just flash some architecture on the screen, you can just take a photo of it and internalize it, you're wrong. And yeah, so characteristics of reinforcement learning. So if you have supervised and unsupervised learning, perhaps this will be a bit new to you, but let's just go through this. So first of all, the goal is to maximize a reward signal for reinforcement learning. The feedback is delayed, not instantaneous. What does that mean, right? Well, in supervised learning, if you're fitting, let's say linear regression, right, you have some data points, you fit, you have a guess, and immediately you can calculate the error on that guess, right, how far your estimate is away from the actual points. It's kind of quote-unquote instantaneous. But in reinforcement learning, a lot of times, you have to step through an environment, the agent has to interact, and over a period of time, right, to collect experience, and only then that when you reach some goal or an informative state, only then will the feedback actually be propagated to the agent. Okay. And the actions of an agent affected subsequent observation it receives in the environment. Right? I mean, this makes sense, right? If I'm an agent and I'm interacting with my environment and I, let's say, move a chair or do something, right? Now my environment has changed, the subsequent states I'll see are changed. Okay, and this is once again different from, let's say, you're training linear regression. You have a fixed data set of points. You just continually fit on that, right? And there's nothing changes. And yeah, data is sequential and not independently and identically distributed. So if you're aware of the IID assumption in supervised learning, reinforcement learning data is not like this, right? The things you see at a particular time step depend on what you've done in the past. Okay, and so there are subtleties here, right? You have to, a lot of the methods in supervised learning might not work, right? And yeah, with that introduction over, before I go on, I just want to check, are there any questions? Okay, perfect, right? Pretty simple so far. Let's get into the goal of RL. Okay, this is sort of an illustrative example. Let's say you are, taking a course at a particular lecture hall, so that's the Bain Center at U of T. You just finished the course and you could do two things, right? You have two actions, quote unquote. You can go home and take a nap, or you can, go somewhere and study. Right? You might see that if you go home and take a nap, you get plus 10 reward, all right? The environment says this is good. You probably want to do that. But if you go and study, it's kind of boring, or you're kind of tired. You do learn some things, but you only get plus 1 reward. Okay, so maybe not as nice. So which action would you prefer at this particular time step, right? Well, obviously going home and taking a nap. That's definitely what I preferred when this scenario happened to me in the past. But let's see what happens, right? We just mentioned how the environment will change, okay? So it makes sense that the actions you take at this time step might influence the rewards or how good you have it in the future. Okay, so right now, going home gets you plus 10 reward, but studying gets you plus 1. So you might say, okay, let's go home, right? But what happens is you go home, you take a nap, and you're inevitably late for your next lecture, right? And this will get you minus 20, right? You miss maybe, what will happen is basically you oversleep and then you think, okay, I just won't go back to lecture, right? It's like, whatever. So you get negative 20 reward. So if you look at the whole scenario, right? Initially you thought going home was good, but actually it takes you to a worse state in the future, okay? But if you had just went and studied, you might have gotten not as high of a reward, but the state you're in is not bad, right? So overall, you probably should have studied. But you can see how sometimes you have to consider future scenarios, right? So how do you do that? Well, a way of quantifying this is we don't want to maximize the immediate reward, okay? So the immediate sort of gratification you get at this particular time step, right? But you want to sort of maximize the total expected reward from all the transitions and all possible future time steps, right? This quantity is called the return. And I believe in AI squared, this is exactly what you want to maximize, right? So let me just quickly go through the definition. So from a particular time step t, the total discounted reward, or the return, g of t, is equal to the reward you get at this time step, plus gamma times the reward you get at the next time step, right? Plus, and if you just look at this equation, gamma squared times the reward you get at 2 time steps from now, and then gamma cubed 3 time steps from now, right? So it kind of makes sense, right? You sort of sum up your rewards. But why do you have this gamma, right? Why is there a discount factor? Does anyone have any idea? Yeah, go ahead. It's kind of along those lines. So basically, the discount factor accounts for sort of the priority of long versus short-term rewards, right? So you can see here that if gamma is 1, then you care about all future rewards equally. So you're very sort of far-sighted, right? You want to prioritize everything in the future. If gamma equals 0, that is exactly the sort of, myopic, short-sighted approach where you really only care about the immediate reward, right? And also, if you think about it a little bit, if you're in a task, let's say you're controlling a nuclear power plant, right? A task never ends. You have to continuously control it. Then gamma, if you don't have a gamma, then the reward will just be infinite, right? So you need some way of discounting so you can have a notion of a finite return in these sort of continuing environments. But yeah, so this is just part of the sort of problem formulation of reinforcement learning, just to get you familiar with it. And so the goal, right? We've reached the goal. We defined g of t. Now we want the goal, all right? Just to maximize the expected return. So notice the definition of g. It's just g, right? But here there's an e here, an expected return. Why is there an expected return, right? Because the environment is random. In the real world, you have a lot of different paths. You have a lot of different things you can take, right? Steps you can take, states you can go to, starting from the current state. And you need a way of accounting for all that randomness, right? You need to account for every possible scenario. That's why you take the expected value or average of the return. To understand, sort of see what I'm getting at, right? G is just the return for one particular trajectory, but you want to account for all possible trajectories, so you take the average of all the sort of things you can possibly see. Okay. So this is the goal of reinforcement learning. Pretty much all your algorithms, and algorithms you'll see out in the fields, or in industry, in academia, mostly in academia, will try to do this, okay? So that's pretty important. Yeah, so this is sort of the reiteration of what we just said, right? An agent should interact over time with its environment in order to achieve a goal. The agent should be able to sense the environment, have clear goals relating to the state. And in relation to that, it wants to maximize the expected return. So now, you might think, okay, so there probably should be some connection between the reward function and a goal you're trying to achieve. And I hope that's what you thought. That'd be good intuition. You should definitely think about that when you're designing your agents in this particular tournament. Okay, and so I'll just want to introduce a quick concept. It's called finite MDPs, Markov decision processes. It's basically what I've said so far, okay? The sort of, wordified version, like sentence-ified version of reinforcement learning, and mathematically defining it, right? So it's a formal definition of reinforcement learning environments. But before I move on to that, does anyone have any questions so far? Okay. Right, so, I just gave you a bunch of examples, or just one probably, like with the state, right? You have the, studying and sleeping example, and you can make an infinite number of examples, but we need a formalization of the reinforcement learning decision-making process to apply this framework to almost any decision-making problem. Now, how do we do this? It's called Markov decision processes. So this is sort of what we've said, right? This diagram might look weird at first, but it's really basically what we've said before, right? You have, you have a state, right? You see your current state, okay, you're at. The agent takes an action in this state, right? The action goes into the environment, and the environment changes, right? And it'll give you the next state and the reward, and just keeps repeating, okay? And what happens is the agent will collect something called a trajectory of experience across time steps, discrete time steps, right? You start in the initial state, you take the first action A0, you get a reward R1, and you transition to S1. Okay, you take A1 and then R2, S2, et cetera, et cetera, et cetera, until perhaps some terminal state, right? Some ending state. So, yeah, so that's basically an overview of an MDP, and these are just the concrete things that are in the MDP, okay? Finite Markov decision processes. You have a state, right, S. You have, or not a state, you have a set of states, right? You have a set of actions, all possible permissible actions in any given state, okay? You have something called a transition dynamics function. I'll get into that. You have the reward function, and you have the discount factor, which we sort of all talked about, right? Just talked about. I think everything else is kind of self-explanatory here, except for the state transition dynamics function, right? And let's see if we, okay, we don't talk about that. So I'll quickly go over that, right? This is basically your environment, right? It determines what state you would transition to if you're in a state and you take an action, right? So you're gonna think of it as, let's say, you know, the wind or something like that in a real environment, where if you take an action of throwing a paper airplane, right, let's say, in outside right now, the weather, the wind, or dynamics will determine where your paper airplane lands up. So this is kind of like that, right? In the real world, there's environments which may be random, right? You take a state, and you may transition to a random next state, right? So you have to think about that in MDPs as well. I hope that sort of makes a bit of sense to everyone. And most of the time, you know, you don't know that, right? You don't know the environment, so yeah, so here's a quick summary of MDPs. Basically, they describe an environment for RL, okay? And almost all reinforcement learning problems can be formalized as MDPs. The MDT formulation can be extended. So we just talked about finite MDPs, right? But the MDP formulation can be extended to include continuous states and actions. And okay, I'm not familiar with your environment for AI squared, but I believe the states are continuous. Oh, okay. States are continuous probably, maybe the actions are too. I'm not sure, but just keep in mind that, you know, we can extend this to continuous action spaces and state spaces. And I'll skip the last point, it's not relevant. Okay, whoa, okay. Inside the RL agent, so I've just sort of went over the goal of reinforcement learning, right? The formal definition of it. But perhaps we want to know, okay, now what tools, what does the agent, the decision-making entity, actually use to make its decisions? There are three things in a reinforcement learning agent. Most of the time, there could be more. And it's a combination of these following things. Sometimes it has one of these, sometimes it has two of these, etc. You have something called a policy. There's something called a value function. And there's something called a model. So the policy is the agent's behavior function, its brain. It's the thing that tells an agent what action to do in this particular state. It's kind of like your brain, right? If I'm in this state, let's go right. If I'm in this state, let's go up or down with 50% chance. For example, that could be a policy. Okay, it's a thing that selects the action. Okay. The value function is a little bit more complicated, and we'll get into this, but it's an agent's belief of how good each state or action is, right? So it's kind of like a summary term. Like let's say you're in this state, and the value is, let's say, like 10, okay? If you're in another state, and the value is like 5, then the agent will know this state value, the one with value 10, is probably a better state than the one with value 5. It's a number that summarizes what the agent believes is the value of that policy, of that state. And maybe action as well. So we'll talk about that. And the model is an agent's representation of the dynamics of the NDP. Recall the dynamics of the environment, right? The wind, the stochasticity, the randomness in the environment. And the model is an agent's attempt to sort of learn that, right? To sort of have an internal version of the environment so that maybe it can, better understand it. But it's out of scope I think, for this talk. So yeah, let me just go over the important things. So the policy is the agent's behavior, or its brain, right? It determines the agent's actions given a state. An agent's policy only depends on its current state, and there's two kinds of policies, deterministic policies and stochastic policies. So this is kind of just reiterating what I said before, but if you're an agent in this particular state S, right? Oh my gosh. Right? That state, right? Your policy will tell you, if I'm in this state, take this action A. Okay, that's it. That's all it is. You can think of it as the agent's brain. And let's talk about these policies, deterministic and stochastic, right? A deterministic policy maps a state to one action with 100% probability. So if I'm in state S0, for example, right? I will always take action A1, okay? If I'm in state S1, I'll always take action A0, and if I'm in state S2, I'll always take action A0. So let's say, this is a particular environment, and this is your policy. You can see it's deterministic, right? If I'm in this particular grid space, I will always go up, okay? So deterministic just means no randomness. And conversely, on the other hand, you have stochastic policies, meaning multiple actions may be selected in this particular state with non-zero probability. Okay, so if you look at this particular policy, right, and let's say you're in particular, and you're in state S0, right, the blue, this particular policy says you go up with 60% probability, you go down with 5% probability, you go left with 20% probability, and you go right with or left with 10% probability, and you go right with 25% probability, right? Notice how the probabilities all sum to 1 for that particular state. So it's sort of like a random policy, kind of, right? There's a chance of picking a particular action. So yeah, so if we have a stochastic policy, then this would be it, right? You can see in some of the states, it's deterministic, meaning you'll pick a particular action with 100% probability. But in, for example, the bottom left state, you can go up or go right with 50% probability. I think this makes sense to everyone, right? What a policy is. It's just a thing that selects the action. Okay, so a value function. I mentioned this before, but it's basically a quantification, a number, okay? Quantifying how good or bad a particular state is. It's defined as the expected return starting in that state and following policy pi. Notice how similar this V, I'll call this function V of S from now, V, how similar it is to the goal, like sort of the goal of reinforcement learning, right? If you recall, the expected return is exactly sort of this definition, okay? But notice this V here has a subscript pi on it. By the way, pi will refer to policy. Okay, policies I'll refer to as pi, but you can see there's a subscript pi there, right? Why is that? Because the value function depends on the current policy. If you have a really bad policy, right, then ideally your value function for that policy will reflect that this policy is really bad, right? So the expected return starting in a particular state, S, and following this policy pi, right, is not very high. And ideally, as you improve your policy, make it better, right, more suited for the environment, the value function will increase as well. Okay, yeah, so why is this powerful? Because it's sort of a summary of everything you'll get in the future, right? It's a summary of your experience in the future into one number. okay? And that number will directly tell you how good or bad this particular state is, right? And just to keep in mind, right, as I said before, the value function depends on the policy and on the starting state. So for every different starting state has a different value, or it could have a different value. A state action value function is Q, okay? But notice here that it takes S and A instead of just S. It's a numerical quantification, once again, a number, of how good or bad our particular state and action is, right? So it's defined as the expected return of, you start in a particular state, you select an action, and you follow policy pi from onwards. So it's very similar to V, but not quite the same, in a sense that you also consider the action, right? So if you have one state, right, and there's two possible actions in that state, you'll have one V of S, right, because V of S only is for that one state. You have two Q of S's for that state, Q of SA's for that state, because you have two actions, okay? And these two things, right, why are they useful, right, is because it sort of, for the particular policy, for the current sort of brain you have, right, policy, it summarizes all your future sort of choices into one number, right? If you're using this policy, right, and in this environment, you might go here, you might go there, right? This particular policy might visit this state a lot, maybe visit this state less, right? All of that is summarized into this one number. So if you have a value function, you can directly see how good your policy is and how good you're doing. So it's a very desirable thing to have in your agent or to model your agent. But the question is, how do you get a value function, right? And this is just sort of me reiterating what I just said. If one state has a higher value than another, you know it's better than the other state, right? The value, you can sort of think of it as like a summary term, right? An aggregation of all your future rewards starting from that state. So it's a very useful quantity to have, because you want to identify the good states and actions, and you have the value function, you can do that. But learning the value function, on the hand, could prove to be challenging. I wish we had more time to go through more examples of value functions. So if you don't get it, please ask me or one of the other, I guess, VP academics here. But yeah, it's a very important quantity that summarizes the total expected return an agent obtains, starting from initial states and following a policy afterward, right? It captures all future rewards, taking the randomness of your policy, right, the stochasticity of your policy and the environment into account. It depends on the starting state, so you could have a different value function or value for every starting state. It depends on the policy, and it depends on the transition dynamics of the environment. Okay, it's a very powerful quantity that summarizes your future experience. Let's do an example, okay? So this is an example of an NDP, right? You have a grid, okay? The reward is 0 for any transition. So let's say you go from, this state to that state, right, or whatever, right? You get 0 reward. But if you bump into a wall, you get -1 reward. Okay, so you don't want to bump into walls. Okay? If you're in A, though, there are two special states here. If you're in state A and you take any action, doesn't matter what action it is, you'll get a reward of +10, and you'll always transition to state A prime down here. If you're in state B and you take any action, you'll get +5 reward, and you'll go to state B prime. So those are the sort of the good states, right? The states you want to be. And the actions in this environment are up, down, left, and right. Okay? North, south, east, and west. And the states are the agent's location in this world. So it could be, 0, 0 could refer to the top left-hand corner, right? Stuff like that. So you can see where the sort of MDP, right, Markov decision process elements are coming in. You have states, right, a finite set of states, a finite set of actions, right, a reward function, so that would be the reward function, +5, +10, etc., right? You might notice there's a couple things missing. What about the transition dynamics, right? Why did I not mention that? Well, that is because, if you think about it, all the transitions here are deterministic, meaning in this state, if you're bottom right, if you go up, you'll definitely end up in this state, okay? It's a deterministic environment, meaning that there's no randomness, right? It could be that in other environments, if you go up, you don't end up in this state, but you might end up in like the top left corner, you might end up in the top right corner with a certain probability, right? But this is a deterministic environment, so you don't really have to care about the transition dynamics. This is not always true. Not all environments are deterministic, right? As I said before, in the real world, if you throw a paper airplane, the wind is not deterministic, right? The wind will blow your airplane here and there, right? So in the real world, it's not. But in this environment, I didn't make mention of the transition probabilities because there are no probabilities, it's always one. Okay, so yeah, so that element of the NDP is still baked into here, but just a little bit more subtle. Okay, there's also a discount factor here, right? If you recall, there's 0.9 up there, meaning that you do care about future rewards, right? Because it's pretty close to 1, but not like completely. Okay, so notice that I just sort of went through all the elements of NDP for this particular environment, and I hope you can see the connection between them. Okay, let's talk about the value function of the policy, okay? Let's assume your policy for this particular environment is a uniform random policy, meaning that in any state, you take the action up, down, left, and right with a 25% chance, okay? So it's a random policy, uniform random. What type of policy is this? Deterministic or stochastic? Yeah. Yeah. Stochastic? Exactly, right? You're getting it. So what is the value function for this policy? Okay. This is it. Now, you might ask, how do I get this value function? There are methods to do so, but we won't go into that now. But just assume that this is the value function. It's a bunch of numbers for each state. Okay? And each of these numbers tells you how good a particular state is following this policy. Starting from this state and following this policy. So if you take this -2 here, right? It's saying that if you start in this state, okay, and you follow the uniform random policy, -2 is the expected total return you'll get from this state. Does everyone understand that? Same with -1.4, okay? If you start in this particular state and you follow the uniform random policy, the expected total return you'll get for all time steps in the future, for everything in the future, it's like this number summarizes everything in the future, because even though the environment is deterministic, right, the policy is stochastic. And I didn't really say there was a terminal state, so you can think of this as a continuing environment, right? The agent will start here and will be like moving all around all over the place, right? If you start in this state and you do all of that following this policy, the average return you'll get is -1.4. And I think this makes sense to you guys, right? Because this is a pretty terrible state to be in, okay? You're next to like 2 walls, so if you act randomly, you'll probably be bumping into the walls all the time, right? Same with these states down here, but you'll notice the states up here have higher value. So these states are probably better under the current policy. And once again, it makes sense, right? Because if you're in this state, you're away from the walls, and you're closer to these sort of, good states, A and B. Now, speaking of these good states, let's take a closer look at A and B. You'll see that the value of state A is 8.8, right? And you might think to yourself, okay, that's interesting, right? Because A gets you +10 reward, no matter what action you take, right? So you might think, okay, so then why is the expected future total, or expected total return starting in state A following this policy lower than 10, right? Because you get a really good, immediate reward of 10. Well, that's because look at where it takes you, right? I said if you're in state A and you take an action, you'll deterministically transition to A prime 100% of the time. But notice how bad A prime is, right? A prime is away from A and B, these good states, and they're very close to all of these walls down here, right? So the value, notice, reflects that. It's lower than 10, right? Even though you get an immediate good reward, the place you'll end up in the future is really bad. And so the rewards you'll get in the future are probably all really bad as well, probably bump into walls, -1. So the value reflects that. If you start in state A and follow a uniform random policy, okay, the average reward or excuse me, the average return you'll get is 8.8, not something above 10, because it'll take you to a worse spot in the future. So you can see now that value functions sort of capture future dependencies. Right, I just answered that. So now you can probably understand why the value of B is higher than the reward it gets, right? Because B will take you to B prime, no matter what action it'll take. And notice that, okay, B prime, I mean, it's not the best state out there, but it's a decent state, right? It's kind of close to A and B, these good states, so there's a chance you might make it back up here again or make it to A again. And it's away from the bad states at the bottom. So the value of B is higher than its immediate reward to reflect that, right? It reflects that the state B is a good state to be in, right? Beyond the myopic view of just its immediate reward. So I hope this sort of drives home the idea a little bit that the value function takes into account the future, right? It goes beyond just the immediate reward, and it sort of summarizes the expected return. So the average return you'll get starting in a state, following this policy, right? So if this policy was different, if it wasn't a uniform random policy, let's say you go up with 70% chance, and you go down left and right with each 10% chance, then the value function will be different, okay? Right, because the randomness sort of is different now, right? Because the policy is different now. So I understand that. The value function depends on the policy. This particular value function is only for this uniform random policy. Okay, so yeah. I'll quickly talk about this because you might see this in doing research for algorithms to use for AI squared. But as I mentioned before, our agents contain a mixture of a policy, value functions, and a model, right? So you could have a value-based policy or agent, which has a value function and no sort of explicit decision-making agent, okay? No policy. You can have a policy-based method, so explicit policy decision-making agent, but no value function. Or actor-critic, which is a policy and a value function. And I think actor-critic is by far the most common. And also you have model-free and model-based, right? You can learn a model, but that's not important. And I just want to stress that, when you're doing research for this, and I'll introduce 3 popular algorithms in RL, it's not like a strict taxonomy, right? It's not like, okay, if you have a policy-based method, it's forbidden to have a value function. But this is sort of how people sort of say it, right? How people sort of classify it. Because you'll see later on that actually some policy-based methods also learn a value function V of S as well. But just letting you know that these are some of the terms you might see out in the wild, especially actor-critic. Reward functions. I just introduced a bunch of general concepts in RL, but I want to talk about something pretty important in RL in general, but also this tournament specifically. I mentioned before that in Markov decision processes, you have a reward. It's something that the environment gives to you, and this is critically important because it's the goal of RL, right? You need to know the reward to calculate the goal of RL to get to the goal. But beyond that, the reward should be informative, right? It should sort of give the agent a signal as to how good it's doing or how bad it's doing, right? So an uninformative reward is not that useful. And the reward is the only sort of feedback the agent gets from the environment. Right, so what happens, what is a reward function, right? It takes in information from the environment and the agent's own actions to provide a numerical reward signal, a number, if you will. Okay, very simple here. The higher the number, the better the agent's doing, the better this action is, right? The reward helps the agent evaluate the effectiveness of its actions in achieving a goal. So yeah, so once again to reiterate, the reward is omnipresent in reinforcement learning, right? Especially the goal, right? Because you want to maximize the expected return. Oh, excuse me, that's a duplicate slide. Sorry about that. You'll have to design your own reward function in this tournament. And I just want to let you see how the nuances of this, right? Let's say you have this environment. It's a cliff world, okay? You want to get from S to G, but you don't want to fall off the cliff. Let's just say that if you fall off the cliff, you define the reward function as having, if you fall off the cliff, you get negative 100 reward. So it's very low reward. Let's say now, though, your reward function is negative 1 per time step, okay? You want to get from S to G as soon as possible. Of course, you have negative 100 reward for falling off the cliff. This is the optimal trajectory for that reward function. Right, makes sense, right? If you get negative 1 for every sort of second or time step you stay in the environment, you're not in G, you want to get to G as fast as possible. And this is the fastest route from S to G. But let me ask you guys this, okay? Is this route, is this trajectory, would you want to do this, right? Is this a good trajectory? Safe. Can someone tell me, is this a good trajectory to have? Maybe, right? It could be good, right? If you want to be fast, that's good. But perhaps you want to consider other things as well. Maybe you care about the safety of your agent. You don't want it to be so close to the cliff, right? But notice that if you have that particular reward function, and you have a learning algorithm that learns the best policy or trajectory given that reward function, this is what it will learn, right? And it might not be what you want. But let's say you have a different reward function, okay? You have negative 100 for falling off the cliff as usual. You have negative 1 per time step as usual. But at every time step, you get negative 1, but you also have some penalty for how close you are to the cliff, okay? So decliff is how close you are to the cliff, and we do inverse it because the closer you are, you want to sort of, you want to penalize it, right? So, yeah, so if you're farther away from the cliff, this quantity will be smaller, right? So negative 1 minus a smaller quantity is, more reward. And alpha is just a hyperparameter that you can control, right, to tune how much you weight the second reward term. Let's say you have, so negative 1 per time step, but you also have this thing here, right, this reward function. I just want to understand this reward function. An optimal trajectory for this reward function now might look like this, right? And now this path might be something you want, right, more than the last path, because it's a bit safe, right? It's kind of fast as well, right? You're kind of taking the second fastest route, but it's also safer, okay? But is it better though, right? Is it just definitely better? Maybe not, right? If you really only care about time, then the first reward function is definitely better. So negative 1 per time step. But let's say you want to care about safety as well, then perhaps the second one is better, okay? But the important thing here is that you want to design your reward to best achieve your goals, okay? And if you have multiple goals, then you probably should have some reward to balance all of these goals. And reward function design is an art. It's a pretty big art when it comes to reinforcement learning problems, okay? So in AI squared, right, what you'll have are rewards perhaps you can define for offense, right? You want to beat other people. So you might reward for the opponent taking damage. So maybe you can have, the magnitude, how much health the opponent lost as a reward, or the negative of that, right? You want the opponent to lose more health, right? If the opponent loses 10 health, minus 10, right? You might want to give the agent 10 reward, okay? Existential, meaning that you can have a reward based on the agent's state in the environment. Well, let's say if there's a region in the game that is dangerous or you don't want to be in, or if there's an edge you don't want to fall off of, maybe you can define what I just did just now, right? A proximity to the edge, a reward based on that. The closer it is, the less reward it'll get, for example. And goal-oriented, right? This is based on milestones. Maybe you can give the opponent, or give yourself rather, plus 100 reward for killing an opponent, or landing a combo, or picking up a weapon. So your reward function would probably be sort of an amalgamation of these three types of rewards. Going back to the cliff reward I just talked about, right? Negative 1 would be a sort of existential reward, negative 1 per time step, and negative 100 right? Falling off the cliff will be sort of a milestone reward. You get negative 100 for falling off the cliff. You don't want to be doing that. So I hope this sort of gets into reward functions and how important it is to have a good one, because the agent, your algorithm, will learn a policy based on the reward function you give it. Okay? And so if your reward function doesn't really reflect the goals, the thing you learn, right, the policy you learn, might not actually be useful. Okay, and let's just wrap up this talk with reinforcement learning algorithms. Which algorithms should you use? This is like one consideration. There are many, but I'll just introduce one. Our algorithms can vary based on what experience they use to train a policy. Some only use current experience, while others use current and past experience. So, okay, so let's say you have this, okay? And this doesn't mean 5 different policies. This just means that you start with the policy at time step 1, you learn something, you receive some feedback, and you update your policy to policy 2. You update your policy again to policy 3, policy 4, policy 5, okay? So let's assume that you have this sort of buffer or this sort of, container of experience, okay? S1, A1, R1. So this is the state at the first time step, the action you took, the reward you got, and S2, so the next state you go in. And let's assume that this is collected by policy 1, S2, A2, R2 is collected by policy 2, et cetera, et cetera, et cetera. Okay? So what this represents is that as you train the policy, right, as you update the policy, change the policy to hopefully make it better, the policy will interact with the environment and collect experience. So notice that S1 and A1 and R1 and S2 was collected by a different policy than S5, A5, R5, and S6. S6. Don't see that, okay? And let's say that right now we're at the 5th time step, and pi 5, so the 5th iteration of the policy, just collected some experience, and you want to use the experience to update the policy to make it better, hopefully. Off-policy algorithms, this is a term you'll see. Off-policy algorithms use the experience collected by the current policy and past policies to update the current policy. So if you want to update pi 5, you'll use all the experience, or you could use all the experience you've seen before. S1, S2, S3, S4, S5. You can only use a subset of it, so maybe you don't want to use S1, maybe it's too far in the past, you don't care about things that far in the past. So you only use S2, S3, S4, S5. Could be. But the point is, off-policy algorithms can use data that wasn't collected by the current policy to update its algorithm, or update its policy. Does everyone see that, right? Recall that S1, S2, S3, and S4 were collected not with pi 5, but pi 1, pi 2, pi 3, pi 4, which are different policies, right? Because those are older policies before the update. Okay. On-policy algorithms, on the other hand, only uses the current experience collected by the current policy to update the current policy. So if you're trying to update pi 5, you would throw away all your past experience, S1, S2, whatever, and only use S5, A5, R5, and S6. This is clear to everyone, right? Recall that S5 was collected with pi 5. A5 was collected with pi 5. Okay, so I don't know, do one of these things seem better to you guys? Like one of these variants are off and on policy? Any thoughts, like which one's better? Okay, just a thought, just get you guys thinking. Oh my gosh. Okay, hopefully, oh my gosh, Jesus. Okay, well I just ruined the slide. But anyways, which algorithm you want to use depends on the environment you're working with, okay? It can depend on it. I mean, this is not a rule, right? These aren't rules, but it's just a guideline as to maybe guide you as to which type of algorithm you want to use. So let's say you're in an environment where rewards are sparse, meaning that rewards are 0 most of the time. Perhaps there's only a positive or negative reward once you reach a milestone, right? For example, in a chess game, right, you might get a reward of 1 for winning the game, but a reward of 0 for everything else. You know, you move a knight, you move a pawn, it's 0. I'll just let you guys think about this, right? Which type of algorithm, off or on policy, would you want to use? That's one situation. Let's say that deployment in the environment is difficult. Let's say you're training an autonomous driving system, right? The agent needs to interact with an environment, the environment being a busy highway. Is it cheap or feasible for, let's say, Tesla to continuously, you know, rent out like highways or just deploy their cars into the highway to collect experience? Right? Perhaps deployment is difficult. And finally, this other situation, the environment is constantly evolving. So let's say, you know, you do something today, okay? Right? The environment is some way today, but tomorrow the environment has drastically changed. Maybe it's weather, right? Today it's sunny, tomorrow it's like there's a snowstorm, for example. Okay, which sort of, you know, policy would you want to use or algorithm you want to use in that regard? I hope you guys have thought about this, and I'll tell you. Now, once again, these aren't guidelines, okay, but this is just my intuition as to why, as to, you know, which ones you should use. And I'll explain my reasoning. So if rewards are sparse, meaning you have 0 most of the time and only 1 informative final transition, you probably, on-policy algorithms might not fare so well, right? Because they only use the current experience, the current trajectory, if you will. And so if the current trajectory has non-informative rewards, like 0 all the time, and only 1 informative reward, right, like time step, then the update to the policy won't be very good, right? However, off-policy algorithms, right, you have past experience. You have like a buffer, a storage container of your past experience. So even if in the current trajectory, current experience, you only have 1 informative state, you might have seen, you know, other informative states in the past. So you can use that to help you update your policy. So that's why off-policy might be a bit more appropriate. Same with deployment in the environment, right? If data is scarce, right, if you can't really deploy that frequently, okay, then you probably also want to use off-policy because, you know, you want to use your past experience as well. You probably want to sort of, you know, use as much data as you can, right? I think that one makes sense. But if the environment is constantly evolving, okay, let's say this week, right, it's sunny and I train the environment for that. But next week, it's, it's a snowstorm or a rainstorm, right? You need an agent to work for that. Do you want the agent, when it's training, you want it to quickly adapt to a rainstorm, to also use the data from when it's sunny? No, you don't, right? You probably only care about your current, environment, your current, like, trajectory you see. So actually, using your past experience might dilute your learning, might, degrade your learning, right? Because the environment is no longer sort of the same as it was before. All this is clear to everyone when you might want to use, on and off policy, okay? Once again, these aren't rules, and these are just sort of things I wanted to say, to give you some thoughts when you're designing for AI squared. So now you can probably think about AI squared, the environment, where Kaden will walk through it real soon. You might think about, okay, can I deploy into the environment very easily? Are the rewards sparse? Should I make the rewards sparse? Should you design the rewards to make it sparse? These are decisions that you might want to think about. And these are the algorithms, these are off-the-shelf, very popular reinforcement learning algorithms that you'll probably use one of these in AI squared, okay? And they're very famous, very well-known, very widespread. The first one is PPO, Proximal Policy Optimization. It's used by OpenAI to train ChatGPT. It's an on-policy algorithm that improves the policy through small updates. There are two terms there that you might look into if you're interested, but I won't go into them here. If you have questions, you can ask us, okay? DQ and DeepQ networks. One of the really I don't want to say earliest, but one of the earlier deep reinforcement learning algorithms that showed its power to solve Atari games and all that. It's a off-policy algorithm. And once again, I won't, go into what these terms mean, right? Target network, experience replay. These are just terms that if you want to research, you'll come across and you should probably know. And then there's also soft actor critic, which is a off-policy algorithm again. And it's kind of like DQN. It's very similar to DQN. But DQN is meant for finite action spaces, while soft actor critic is meant for continuous action spaces. Okay. So, yeah. And so it was invented at Berkeley, but anyway. So these are just algorithms that hopefully you'll learn about, and you'll probably use one of these in your AI squared projects. If you have any questions, feel free to ask one of us, but I just want to throw these terms out there so you can sort of make a decision based of what algorithm you want to use and what you want to research. Okay, that's it for this talk. Thank you for listening. Good luck with your projects. If you have any questions, feel free to ask around, and I'm sure many of us will be happy to help. Okay, thank you. Thank you.
Yeah, thank you, Jingmin, for the really great talk. I guess one more round of applause. Yeah. Yeah, we also have, if you want to learn more, we have the reinforcement learning workshop actually recorded on our YouTube channel. So if you search up UTMIST on YouTube, you can find his talks. Yeah.
So all these concepts go into a lot more detail. So.
Okay, yeah.
So yeah, please feel free to.
Yeah, and then we're gonna go for maybe a 5-minute break, and then we're gonna have Kaden and Martin come up here and give you guys a Codebase walkthrough. Yeah, so we'll be back maybe in 5 minutes. introduce Kaden and Martin, who actually they're the game dev leads. So they actually built the game that you guys are going to be working on. Yeah, I'll let them introduce themselves, and yeah.
Okay, thank you, Jessica. So hi, I'm Kaden. This year I'm co-VP academics with Jessica, but last year I was also leading the AI Squared project. This year I'm doing it with Martin. So yeah, I'll also let Martin introduce yourself too.
Hi, my name is Martin. I'm second year engineering science, and I'm the game dev lead for this year. Yeah.
Okay, yeah. So I guess before we get started with the actual Codebase walkthrough, just want to mention this is our GitHub repository. So basically when you guys participate, you actually have to create a fork of your repository, and then you guys will be working on that when you build your agents. So basically just how to do that real quick. So if you guys all have github.com/utimist AI squared as your link, and basically in your group, if one member could just fork this repo, create your own copy of the repo, and then you just share it to all your teammates, you'll be able to start working on your project. So I just want to mention that quickly. And yeah, I think with that, we'll get started with the actual Codebase walkthrough, where we'll take you through the technical guide notebook and all the specifics. Yeah, so environment API, Martin, would you like to get started?
Yeah, so the environment API is basically a collection of variables and functions that we have provided to make it easier for you to access information about the game environment. This is pretty critical for designing the reward functions to cater your agent to specific requirements or needs that you desire. To preface, I'm first going to talk about the map, a little bit of information. Scrolling down. So this is an image of our map. So there's some key features. Firstly, we have 3 platforms. So there's 2 stationary platforms, which we call ground 1 and ground 2. They don't move. There's also a moving platform, which we call moving stage, which moves between those 2 red endpoints, there and there. In terms of the coordinate system, there is an origin, which is 0, 0, in the center of the screen. And the positive X direction is from left to right. And kind of weirdly, the positive Y direction is from the top of the screen to the bottom. I would recommend, so the screen dimensions are 14.9 by 9.94 game units. If you bring this image into some video editing software and you scale it, it'll be very easy to identify certain areas or certain points that you might consider for your reward functions. For example, if you want to bias your agent towards staying on maybe the higher ground, then you can find the coordinates of that area and work off that. Yeah, now I'm going to talk about spawners and weapons. So if you participated last year, you didn't see that. So this is a new feature that we're adding this year. Okay, the images aren't showing, but there's basically 3 different types of weapons. So by default, when you spawn in, you're equipping a punch weapon. And based off equipping some random spawners or any spawner, you can equip a hammer or a spear weapon that we've provided. In terms of spawners, there are 2 different types. There's a random spawner, which will appear as a glowing sword that drops in. When you equip it, a random weapon will be equipped. There's also a dropped weapon spawner, which basically appears when an agent's equipped weapon is dropped. That will just appear as either the spear or hammer, depending on which weapon was previously equipped to. Moving on to the important stuff. So environment variables, this is specifically what you guys will interact with. This is the information you need to know. This is how you access the information from the environment, which you can use for your agent. So 2 of the key objects are env.objects player and env.objects opponent. This is how you access information about the agents. So player agent is the agent that you'll be training, and opponent is basically the opposing agent. So some information we have about these agents, we have position, which is accessed through body.position. It's basically XY coordinates. There's also X change and Y change, velocity X, velocity Y. We've also included a couple characteristics. For example, damage taken total, which is the total damage taken over the entire game. And there's also damage taken this stock. So if you guys ever play video games, a stock is basically like a life. In AI squared, I believe you have 3 lives or 3 stocks. So the damage taken this stock would be basically the damage taken in the life. As well, there's also damage taken at this particular frame or time step. In terms of time, there's time elapsed, which is basically the amount of seconds that have elapsed since the start of the game, and current frame, which is the current frame number. Moving on, so these variables are regarding the spawners, weapons, and platforms. So to access the particular weapon of your agent, you're going to use env.objectsPlayer or env.objectsOpponent and use the .weapon parameter. So it can either be punch, hammer, or spear. Importantly, these are strings which are capitalized on the first letter. We've also included information regarding the moving platform, which we've labeled platform 1. So body.position will be the position, and velocity X, velocity Y will be the velocity. To access information about active spawners, you're going to use spawners.equal env.get spawner info. This will basically return an array where each entry represents one particular active spawner. Each entry is in the form of 2 things. Firstly, weapon type and world position. So the weapon type will be either spear, punch, or hammer, or random if it's a random spawner. World position is just the XY coordinates.
Okay, yeah. So that should explain the environment API and the key variables that you will access. So now, just to discuss the reward function library. So this is like probably going to be the most important thing you do, and it was probably covered in the previous workshop. So like, but yeah, reward functions are important, right? Because they kind of, because they loop when the agent interacts with the environment, and the agent gets reward, and that's how it performs better. So reward functions influence an agent's behavior. And in this section, we'll basically teach you how some examples of good reward functions and some ideas that you can base off of for designing your own, and also how would you build reward functions in our code base. So yeah, I guess, did you want to explain this one? Yeah.
So the first one we're going to talk about is a damage interaction reward. So this is basically a reward based on damage taken and damage dealt. So the key variable in this reward function, the key parameter in this function is mode. So there are 3 modes. There's offensive mode, symmetric mode, and defensive mode. Scrolling down, we can see the if-else statement. So if the mode is offensive, the reward will be essentially fully dependent on damage dealt, so it'll really prioritize offense. If the mode is defensive, the reward will be a negative reward based on damage taken, so it'll prioritize avoiding damage taken. If the reward mode is symmetric, the reward will be based on both offense and defense, so based on both damage dealt and damage taken. Caden, next one.
And yeah, and another type of reward, we have a danger zone reward. So basically, oh, okay, I'm gonna zoom back out again. But yeah, like basically you'll see that at the bottom, right, when you're really close at the bottom, that's danger zone because you can fall and die. But yeah, so basically this is an essential reward because it's always active at every time step, and I'm gonna zoom back in again so you can see. But basically, it's always checking if the position is in the zone height, then we will apply that negative reward. Otherwise, there will be no reward given. And yeah, so also in this notebook, you'll also find it in the repository under the guides folder. This is just to give you an idea. It's not implemented by us, but it's something that you can try for yourself. And moving on to another section, modular existential, basically means like it's modulated by some property of the environment. So like in this case, move to opponent reward only occurs when there's movement made by the player towards the opponent. And just to quickly take you through this, just for the sake of time, I'm going to go a bit quicker. But basically, just have a position and a direction, and using that, we can compute a dot product, basically to figure out how much the current movement is in alignment with the direction they need to go in. And they will get a reward based on only that change. And yeah, again, this is a to-do for EdgeGuard reward, but also to give you an idea of something you might want to consider when you do develop your agents.
Okay, so single event sparse rewards. So a lot of the rewards we talked about earlier are basically time step dependent. So these are reward functions that are called every time step. Sparse rewards differ in that they are called when a particular event occurs. In the technical guide, we've had a section explaining how to implement unique signals, but for the sake of time, I think we're going to explain the ones we've implemented. You can still specify these and cater it to your own needs because you can define the reward function, but we've handled creating the event emitters for you guys. So the first one I'd like to talk about is knockout reward. So this function is called when there's a knockout that occurs. Some key parameters include agent and mode. So agent will be basically player if the player is knocked out, and will be opponent if the opponent is knocked out. Similar to a previous reward I discussed, there's mode, which can be asymmetric opponent, player, or symmetric. So if the mode is opponent, a positive reward is given if the opponent is knocked out. If it's a symmetric player, a negative reward is given if the player is knocked out. And if it's symmetric, it'll be based on both.
And yeah, and I guess for win reward, same idea, like the win value would be given if the player agent wins, otherwise it will lose. And yeah, these are just more equip or drop rewards based on if the agent picks up a weapon or drops a weapon, and we have that signal for you too. And yeah, just gonna move on to the final section now. So the training process is probably gonna be like the most important thing for you, right? Because you're training your agent in AI Squared. But basically, you'll see a file called trainagent.py in the user folder when you open the repo. And you'll be using this to basically edit the file and train your agent. And basically, just to point out quickly, the structure of this section is exactly what you'll see in that file. So just to take you guys through the steps of what's happening. So first is defining your agent type. In the file, we have provided a bunch of various types of agents that extend an agent base class. There are many agents that we won't have time to go through in this walkthrough, but we'll leave that for you guys to explore when you go through the file. But yeah, like you can define agents like SB3 agents or running RL algorithms, or a base agent if you guys want to make an if statement algorithm-based agent or hard-coded one. And if you guys do want to implement some sort of custom agent, this is the class given below. But I do want to stress that we do have like agent templates for you guys to reference as well. But yeah, I'll let you guys look at that on your own. And yeah, the reward function API. So basically, in the last section, we've discussed all about reward functions and basically how to make effective ones, how to just make them in our code base, but how do we actually like use them, right? So basically for this, we have a function called generate reward manager in our file. And here you'll be compiling all the rewards that you use. So for example, actually not for example, but basically for every reward we would have, you would put it in a wrapper called reward term. You would put your reward function as an argument there. You'd put a weight, so weight basically would be scaling your reward based on how important it is, and that's for you guys to change and adjust as well. And if your reward function has some sort of parameter, you'd be putting it in a dictionary argument or input here as well. And you would basically be compiling just the name of the reward function and the reward terms. And it's the same idea for the signal subscriptions, but you'll also be putting the signal name and the reward terms for that as well. And the train function. So basically, if at the very bottom of the file, you'll see like if name equals main and then some code. Oh, okay, this just powered off. But basically, yeah, you'll first be initializing your agent. So basically, if you're gonna start training from scratch, you would initialize an agent with no file path. So basically, you'll see here, there isn't like any input. But if you do want to continue training a model from a specific time step, then you would put the file path of the model. And the next part of what you can change is the self-play settings. So we have self-play random or self-play latest for training. Basically, self-play latest will always learn against the latest saved model. And self-play random will learn against a full randomly selected list of previously saved models. By default, it's set to self-play random, but you guys can also mess around with that, see what works best. And we'll also have a save handler as well, so configurations for saving your agent for self-play. So basically, you have your agent to save, a save frequency, max number of saved models, and yeah, like all the parameters. So this is where you would save your model, and then you have a mode, which is force or resume. If you are continuing training from a specific time step, though, you have to make sure that your save path is like consistent with that previous training session, and also make sure that your mode is set to save handler mode .resume, so that you can resume training. And we also have an opponent config that you can basically switch up as well. So this basically has like the probability to play against a specific agent and the agent. So yeah, like that is there as well. And I'm going a bit faster because we were almost out of time. But you can, and yeah, you can also run a demo match locally. So like for our final section. So once you have an input agent and a submitted agent, like you can actually load in your model. And what a user input does here is like, that's you playing, so you can actually play against your own AI, which is really cool. But yeah, like you can put any agent's argument there, and it will work out nicely. And I know like it is getting a bit over time, but I do want to kind of like show you guys how that training process works like visually, because you know, all we've been doing up to this point is just talking. So I think like a visual example real quick would be good. So. Yeah, I'll just quickly show you guys how to do it, and yeah, so like you'll see in our train agent.py, you can see how the structure, everything is defined, so our rewards and all that. I'm kind of just scrolling through really quickly now. But yeah, like you can see how all my things are kind of defined. Don't worry about this. But I'm gonna just use recurrent PPO agent to be consistent with our notebook. And yeah, like all my configs are defined, same values in the notebook, and I'm just going to try training his. Okay, wait, yeah, so basically how I'm gonna run this is Python m user train agent, and hopefully this goes well. Oh, no, wait. Did I import Jim? Okay, that's not. No. Okay. Sorry, guys. Give me 1 sec. Where is this? Train agent. Jim. Okay, I'm just gonna delete that real quick, because who needs Jim? Okay, I'm gonna try again. Okay, let me see. Okay, yeah. So you'll see that like I didn't change the folder, but like if you do have a force, you either have to clear the folder, or if you answer no, then it will probably break. Yeah. So yeah, just remember if you are starting training, then you have to use resume. Yes. Yeah, and so now you'll see like it's training. So basically the spawners are just info from the environment, but you can see like there's like selected self-play and all that. Currently you'll see that there's no self-play model saved yet because the model just hasn't been saved because I have the config that like saving at every 100,000 time steps. But yeah, just to quickly show you what that would look like. And yeah, I'm just going to quickly end that real quick. And then when you end training, you'll see that, okay, I have so many folders open, but you'll see that basically it's saved in experiment 8, because that's where I set my, or a checkpoints / experiment 8, that's where I set my model to be saved. So now I can just copy this, just copy the name here. Then if I want to test it, I can go back to this user folder, and I can go into demo match. And basically, here, if you're loading in a model, you could do, can you hold my mic? Thank you. But you could do file path equals this, or, well, the full file path actually. So checkpoints / I can't spell, / experiment 8 / this, and hopefully this works. Oh, wait, I also want to, and yeah, if you want to run a real-time match, you use real-time match. Wait, what the PvP? I swear some things have changed since I last touched this. Okay, I'm gonna copy this over, paste this in, and I'm gonna try running. Oh, I forgot an M, my bad. I'm gonna type, oh, it's not a train agent either. Okay, I'm gonna type this in, python-m user.demo match, and, oh, please. Oh yeah, and then yeah, you can see like the blue agent, like it sucks. It sucks because it's not trained, but guys, that's your job in AI Squared. Train an agent to not suck and win the tournament. Thank you.
Thank you.
Yeah. Does this get you guys excited? All right, let's go, man. Yeah, so I guess thank you, Caden and Martin, for that wonderful demo. And honestly, like they're also mentors. So like if you guys want to ask any questions, like there's a mentor section where you can submit questions and they'll be able to help. Yeah, right now we do have lunch right outside in the lobby. So if you guys want to go and grab lunch, feel free to. And literally right now, I'm just going to send the message for the submission for the team formation forms for the submission pipeline. So if you guys check announcements, if you have a team, make sure to fill out that form. Otherwise, your agent might not be considered. All right, thank you guys. You guys can head out for lunch now.
Waiting for the second, baby, never make a sound. If you never hear from me, all the satellites are down. Yeah, they're all down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down? satellites are down, yeah, they're all down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down? Pixelated kisses got me going insane. Replicate this moment from a million miles away. Waiting for the signal, baby, never make a sound. If you never hear from me, all the satellites are down. Yeah, they're all down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down?
Hi guys, welcome back from lunch. Yeah, we have Russell here from Artificial Agency, and yeah, Artificial Agency, as I explained, they're one of they're a gold sponsor. Yeah, and they do a lot of really cool stuff with AI and gaming. They make like a game engine, a game behavior engine. The details I don't know about too much, but I think that like if I'll let Russ take over. Yeah. So everyone, welcome our speaker, please.
Thanks, Jess. Hi, everybody. So my name is Russell Sung, and that QR code goes to my LinkedIn. And I thought, what would be the best use of your hour after lunch? And I feel like since you're already going to be building agents into what you're doing for AI Squared, it'd be interesting to give you some insights into how the industry as a whole is looking at deploying agentic behavior into their games. And maybe give you a little bit of an insight into my journey from indie into the forefront of AI and basically how to go from zero to cracked, because I feel like that's pretty important for you guys. So these are kind of the 3 ways that I progressed through where I was today. I've started my journey in Ontario Tech. So when I went, it was called the University of Ontario Institute of Technology, and it was the only accredited program for game development and entrepreneurship at the time. Nowadays, you can go to Humber, you can go to Durham, you can go to a lot of universities and colleges that have certifications, but at the time, this was the only undergrad that was available to me. And so I was like, well, I like games, but fun fact, the University of Ontario Institute of Technology Game Development Entrepreneurship 4-year program had a higher attrition rate than nuclear engineering at the school. So with my cohort, I think I had 125 students enter first year, less than 20 of us graduated, right? So the attrition rate is pretty ridiculous. And I think that's because people confuse playing games with making games. And that's a clear difference that I think it applies to a lot of fields out there. So I made XR games. It was amazing. Published some to the Quest Store with an indie studio out in Toronto called Stitch Media, or Games by Stitch. And the second one was actually an award-winning one. The first one wasn't, but the second one was. So there's a little bit of an analogy in there about how you should persevere, which we'll tie into later again. After that, I worked on some really interesting projects that I cared about that weren't just in games, but were still using XR. So this was like brain injury rehabilitation. These were a walking simulator for the University Health Network, all in XR, helping people with real problems solve them. So after that, I joined Unity, like the Unity, where I was part of the go-to-market team. Technically, I was a developer advocate. And if you don't know what a developer advocate is, it's like technical marketing, technical sales engineering. We had the SDKs fresh from the engineering team. We would make demos. We would go to conferences. We would go pitch. And so I got really comfortable with talking to developers and helping them understand, as a developer myself, why this SDK could solve those problems. So everything from multiplay servers to Unity ads to like cloud content delivery, so CMS systems at scale. So we're talking about like Marvel Snap, how they managed to do cloud content delivery or content delivery at scale without having to download all of these hundreds and hundreds of images onto your phone. So we were part of that initiative. I was then headhunted out of Unity to join InWorld. So InWorld AI, if you look it up on my profile there, one of the best funded startups making AI feasible for games. They've pivoted now to like runtime stuff, but when I was there, we were locked in on games. And so we got to work with customers like NVIDIA and Microsoft to pioneer what was possible with AI in games, specifically on the avatar piece. So the embodiment, the personality, the memory. Basically, we were like one of the earliest customers of 11 Labs. So shout out Maddie at 11 Labs. That included also publishing games to Steam. So actually, it's still there if you have the key, but it was called Origins, and it was basically an Unreal Engine demo of InWorld. So you could like talk through this dystopian world, find out what happened in this really, really interesting sci-fi experience. And that was where we pioneered a lot of what AI looks like in games. And now we're building, the next stage is building the future. So I've explored the AI avatar piece. Now at Artificial Agency, we are exploring the agentic piece. So not just what the character says, but what it decides to do before it says anything. The goals that that character may have in the world that it has, how it perceives the world, and how it acts to achieve those goals that it has. And fortunately, I get to work with some really interesting companies that you will see in Q1 of next year, deploying agentic behavior into their games at production. So you can say 2023 was like the year of discovery, 2024 was the year of prototyping, and now that 2025 is coming to an end, the year of like putting it into production, and 2026 would be the year of launching. So yeah, I bring a unique perspective because I'm very, very fortunate to have shaped my career to join and work at the top 3 AI and games companies in the world. And we work with companies that, like I said, Microsoft, NVIDIA, Ubisoft, really getting the chance to understand behind the scenes what game studios are focused on and what they're trying to solve. I just want to build Jarvis. Like, I'm just shaping the world to build Jarvis. So I actually truly believe that the first solo unicorn is from your generation of entrepreneurs. So I'm just like also positioning myself to get hired by you in the future. So shout out 2025. So here are how game studios are thinking about agentic trends. All right, so number 1 is QA and testing. So as you know, software devs to be, you understand that automated QA is like the future, not having to sit down in front of like a software development and test, and unit test, and unit test, and unit test. What if we could just have agents that play your game and run through your code and understand where your bugs are? So what you're going to see is shorter development times. So you're going to see games that were traditionally taking 3 or 4 years come down to like 1 or 2. You're going to see patch cycles shortened as well. Because honestly, the majority of the time that a patch takes is not the patching. It's actually the validation with the consoles. So Xbox and PlayStation and Nintendo, they obviously don't want you to have buggy software. So whenever you submit a patch for validation, it goes through a whole process with them. And that can take like weeks to months. Whereas the content that you're just trying to fix could be like 2 pull requests, right? So QA is a big piece, and testing as well. Adaptive gameplay. So we all know in game dev that we have had behavior trees, and we've had A-star pathfinding, and we've had AI in games for a long, long time. But now we're having dynamic generative AI in games. So what this means is that you could have truly adaptive difficulty. So if you're playing like Elden Ring and you continuously just like facepalm into the boss, maybe things adapt without you having to change anything, right? And it kind of happens a little bit in scripted areas, right? Where, you know, sometimes the first time you beat a boss, depending on how fast you beat the boss, the second phase is harder or easier, or vice versa. But we are looking at much more dynamic, emergent gameplay behaviors. One of the companies that we're working with is a Among Us / haunted house. So the house itself is trying to like also eat you while you're trying to defeat your other players. And that really is only possible because of Gen AI in games. So the house itself is an agent trying to accomplish its own goals, independent from the player. Of course, we have content creation in terms of story. So language models are really good at, you know, weaving narratives together and making something cohesive out of disparate inputs. And so imagine if you could, as a role-playing game, really have a personalized experience that's independent from the person next to you that you can then talk about and share about. So that's what we're really excited about too. And hyper-personalization. So imagine if you're a DM in a Dungeon Master or D&D game, being able to craft these hyper-personalized experiences for your players. Now imagine if the DM was an agent that is just there to help entertain you, make sure that you're enjoying your experience with your friends, and really able to, you know, look at your choices and adapt to what's happening. Yeah, so that ends the kind of corporate part of it. I would love to spend some time kind of explaining how I was able to move through the industry, because when I was in your seats, I didn't have somebody to do that for me. And now you have the fortunate space of the mentorship that is available to you, which is like incredible. So step one that I thought was really good was moving forward with intention. So shout out Stephanie for the boba. I did not have a boba, and then I was like, I would like a boba, Stephanie, and she magically made one appear. So the lesson behind that is if you don't ask, you'll never know, right? A lot of my mentees at your stage of your career, they're afraid to ask, and then you don't get boba. Just ask. That's part of striving with intention. Like when you make your next decision or your next choice or your, even your next push to your repo, like, is this intentional or is this just for the sake of it? All right? Imposter syndrome. So, I also still struggle with this. And if I'm doing it, I'm sure many of you are in the same position as well, right? Like you scroll through LinkedIn or Instagram and then you see your peers in like YC or in A16 speedrun and they're like, oh, I'm building the future. And then you're like, well, what am I doing? You're on your own path, and that's okay. All right, I'm going to say it again for those in the back. You are on your own path, and that is okay. A lot of times, people do not share their failures and they only share their successes. That is not accurate of the real business world, and that is not accurate of how things actually go in industry. There will be many times where your code review is just complete garbage, and your like senior dev is like, why are you even here? And it's up to you to decide how to take that feedback and move forward with construction or, basically lose sight of why you're there. Documenting your wins. So it may seem trivial, but if you are proud of something, recognize it and embrace it and understand that this is something that is pretty awesome, right? Whether it's your first function that works in a code base at prod, whether you push something to dev and it didn't break everything, those are things that you can celebrate and enjoy. Sharing your struggles. So like I talked about before, there's a tendency to glaze everything. That's what you kids say. And the truth is that progress is not linear. Okay, I'm going to say that again for those in the back. Progress is not linear, and that is okay. Sometimes you will be stuck in a flat plane, and then your next step will be exponential, and you'll be like, whoa, what happened? It's because you kept grinding, right? Like we're only human, and sometimes it's hard to understand that progress is not linear. Embracing yet. So one of the things that a lot of mentees that I have in the Gen Z and Gen Alpha, you do have this vivacity of ambition, which I think is incredible. I think your generation is going to really positively affect the world. And so embrace the idea that you don't know something yet. I can't do this yet. I'm not good enough yet, right? I think the sooner you understand that you are on a journey of progress, the sooner you will understand how capable you can be. And I truly believe that. Intentional action. So this is kind of leading into the conversation of well, Russell, you had such a cool start in XR, and then you started working in games. And that was because when I went into my university program and survived this over 50% attrition rate per annum, by the way, it wasn't because I was super smart and super capable. It's because I moved forward with intention. I knew that I wanted to make an impact on the world, and I wanted to make cool stuff with technology, and I thought that games was a great way to do that. And so make sure that as you move towards your goals, you have a clear understanding of this is what I want to accomplish. If you want to be a Sui and Fang, that's it, and that's okay. Do that, but make sure you understand, why. Is it for the clout? Is it because you want to live in SF? I can tell you, I've been to SF many, many times as somebody who works in this industry. It's aight. It's aight. You're gonna go there and you'll be like, whoa, where's my free healthcare? Why does everybody have guns? I would visit SF, and I've worked in SF, but I wouldn't live in SF. And that's not to say that people who want to do that have any, that's fine too. But understand what you're getting yourself into when you go to SF. We have some of the best talent in the world when it comes to software devs. If you look at any top-tier, tier-1 firm for AI, for Sui, Canadians are at the top. We're just there. They come from Waterloo, they come from U of T, they come from University of Alberta, they come from UBC. So be proud, right? but move forward with intention. Micro goals. This one's super key. Like, I don't know why some people step into the world and like the first thing I'm gonna do is get 6 or 7 figures as a SWE. No, the first thing you're gonna do as a first-year grad is like join a hackathon and like understand how to work in a team and like make a pull request, right? Set micro goals that get you to where you're trying to go. Then it doesn't feel so daunting as you're moving towards that overarching goal. Rituals, not habits. So this is pretty clear. You want to enforce good behaviors on your own part. Like if you do something repeatedly, habitually, if you move forward with intention, you're going to be able to accomplish your goals. Like build habits, right? Sorry, build rituals, not habits. Reflect and adjust. This part really is like mentorship more than anything. Have somebody that is where you are, and then have somebody that's where you want to be. And these are the people that will help keep you accountable, right? Like there's a reason that hacker houses exist. It's not because a bunch of introverts really like living with other introverts. It's because when you pitch your idea, you get real honest feedback really fast, and you get an understanding of like, does this work or does this not work? Yeah, so it's in community. I want to get to the AMA part. So basically, you all know what this is. The idea is, find what you love. Find the intersection that doing it helps the world, and find somebody to pay you to do it, right? It's a very simple concept, Ikigai. And pursue the Kaizen. So another great Japanese philosophy. You don't have to improve by 10% every day, because that's not really feasible, but if you improve by 1% every day, after 100 days, guess where you're at, right? It's just math. It's really just math. Continuously try to improve. If it's just one line of code better, if it's one function parameter that doesn't suck, if it's a proper comment on your code, just one line makes you better as a developer, and honestly, you can apply this to a lot of things in your personal life too. Yeah, 1% better, learning from everybody, and iterate fearlessly. So don't get stuck thinking like this is the one thing that I'm going to build and it's going to be the only thing ever. Just throw out prototypes, especially now with the tools that you have available with vibe coding. Like you can get to a really strong initial prototype really, really fast, but only if you move forward with the intention that you're going to keep breaking things and it's going to suck. It's going to keep sucking until it stops sucking, and you're like, wow, I actually got here. Yeah. Okay, so that's the recap slide, but I would like to go to the AMA. Please, this is your opportunity, and somebody will run around with a microphone.
I just want to say, like, if you have a question, just raise up your hand, and like Elvin will be the one running around. Yeah.
So as far as Gen AI in gaming goes, I always end up hearing, all right, that it uses a ton of electricity, ton of power to get going. And so how would that work on like on a home computer or a home console or something like that?
Yeah, great question. So we are moving towards on-device compute, or edge compute as it's called. And the goal is that we don't want the users to pay for their inference, right? At the end of the day, it's really interesting because unlike traditional B2B or B2C SaaS, the more users you have with AI, it can be actually, a bad thing because you're spending more compute. But it all comes down to the new economics of what's happening, right? Like if we can move the inference to devices, then they're already using, like I would say most of the 2023 and beyond MacBooks and laptops have these like neural processing units that are just underutilized anyway, right? So you could actually run your own Copilot off your device. It may not be as robust as like Claude Code or the bigger models, but we're getting there. We're making models smaller and more efficient, and therefore take up less energy, and you don't have to pay for inference. Good question.
Hi. So you mentioned about Gen AI in soul games or like indie games like Elden Ring, God of War, stuff like that.
Mm-hmm.
But what about the use of Gen AI in more multiplayer games like Battle Royale, such as Fortnite or COD? How would they affect the game, and how would the player base respond to it?
Yep. So two ways. One is anti-cheat. So there's a war on anti-cheat happening. And even in like Roblox and Fortnite, there's tons of bots. So why not use AI to detect AI? Another piece is making multiplayer feel more alive if there aren't actually players yet. So a lot of times for the Battlefield servers now, if they're underpopulated, they get filled with bots, and the bots are like not great. So what if you could actually participate in a round where it feels engaging and competitive until people actually join? So those are the ways that I would anticipate and are being used for AI in games. And another thing is like the level itself, right? Like beyond just destruction that happens as you go through the game. I mean like things that can shift the tide of battle dramatically, right? Like maybe new pathways open up to access new areas or mechanics change on the map. And those are triggered not just by scripted actions and behaviors, but like an AI director watching what the players are doing and changing what happens.
Sorry, I have a follow-up question. So my question was more like, in those bots, if we use Gen AI and they're like really good generative AI and they learn during the course of the game, won't they eventually become better than the actual players? And how would the players respond to that? Because they spent years trying to learn those mechanics and then AI is just copying those.
So, well, I'm sure you understand the concept of like underfitting and overfitting, right? So the idea is that you want to be very, very clear with your limits of the AI, right? There's going to be like an easy mode, medium, and hard mode. It kind of tweaks to your AI, and all it really comes down to is like data. Honestly, the reason why games are such a huge medium for these AI companies is because it's almost an unlimited amount of simulated data, which you can't really get in the real world anymore. Like we've tapped out. We have tapped out on the available data of the internet. But we haven't tapped out on the interactions and mechanics and the worlds of virtual games. That's really why these AI and ML companies are there, because they are hungry for this data. Like if you think about building a data center or building a robotics-powered manufacturing like factory, you can simulate that right now in Unity or Unreal and prototype and like run thousands and thousands of robotics. And that's what they're doing with the Cosmos, like with the world models from NVIDIA, with World Labs. They're building these models to be able to physically simulate the real world in 3D spaces. So yeah, it's deeper than gaming, but it's starting here.
Hi. So
Hi.
I think agentic AI has a lot of potential, but right now it's like pretty easy to tell when something is made with AI. So do you think it will ever get to the same level and like authenticity as code made by a real person?
It's a good question. I think it depends on the objectives of the game developer. I think today, I could replace myself with a digital twin of myself, including my voice, and it would be imperceptible. But is that the goal of the like engagement that I'm doing here today? So if you're trying to maybe weave a story, like a narrative adventure, maybe like Cyberpunk. Cyberpunk fits very nicely, obviously, because of the setting of the world. But you could, today, have like a Cyberpunk-esque bartender, be very, very realistic, have personalized like traits and language even and appearance to your experience as a player. The question is like, do we still want to maintain this facade and illusion that you're interacting with a virtual character? Like there's certain things that you can do because the other side of the party is virtual versus like the things and behaviors that the way you interact with another human. And so it's just up to the developer, like do we want to cross that barrier? It's not a question of technology, it's just a question of intention. Great question. Also, I appreciate that you're all asking me like AI agent questions, but really, if you do want a deep dive, I'm here for it. Like, yes.
Hi there. I was kind of wondering, how did you first, what did you do to get your first job in the video game industry?
Yeah, good question. I worked for free, and it sucked. Yeah, I took up internships at companies and startups that I thought were doing interesting things, and I literally put in the resume, I was like, I will work for free for the experience. Do not do this anymore. Your time and effort is more valuable than mine was in, I don't know, 2017, 2016. But I got to work on some cool stuff. Like one of my early projects that I did get paid for was as a Unity developer for a company called 20 Billion Neurons. And this was like 2018. And they were using like CNNs to do computer vision, and actually they paid like a bunch of people on Fiverr and around the world, like Mechanical Turk, to submit clips of like waving or smiling or thumbs up or thumbs down, because they needed all of this training data for their neural net. And we were basically building like a kiosk that you could talk to and interact with, and this was pre-GPT, so you can only imagine the challenges involved. And I was doing the Unity front end. So everything from like character animation and rigging and like the outfits and basically interpreting what the message stack from the Python TensorFlow backend was trying to communicate and then acting on that. But I got a chance to learn about machine learning at that time and like natural language processing. Yeah, good question.
Is it okay if I ask one more then?
Yeah.
So given that, how would you recommend we go about getting our first job in the industry today?
Join hackathons. A lot of times hackathons are being judged by people in industry. Spoiler alert, they're there to hire you, not actually judge your like projects. They're just scouting for talent. So just be the best.
Like yourself?
I mean, I would say like, I'll sit in the top 20%. There's always room to grow, but shout out for the glazing. You see, Gen Z glazing.
Thank you.
Like 30 minutes, right? 12, like 2:30? Nice, that's good. We could talk about gaming industry trends as well if you're interested in that. Beyond like AI, I mean like UGC and stuff like that. Go ahead.
Hello. I was wondering if most of these like AI agents for games are primarily done with reinforcement learning.
Sorry, can you repeat the second half of the question? I just didn't catch it.
Are most of these AI agents being trained with reinforcement learning?
Great question. So Artificial Agency is actually a reinforcement learning first institute. Our founders were part of Rich Sutton's postdoc team, like the team that built AlphaGo, the teams that built the first poker simulation, like perfect, quote unquote, perfect poker player. And these were all reinforcement learning based paradigms. So if you look at the structure of a game, it's basically like almost purpose built for reinforcement learning, right? Like there's a cost function, there's a clear win strategy, there's a clear lose condition, because that's basically what a game is. If you think of Elden Ring, it's a reinforcement learning cycle, so you just stop sucking at boss fights. Like, you just keep getting face smashed until you stop being bad, right? So that's reinforcement learning, but for humans. So yeah, reinforcement learning will continue to be, fun fact, the R in DeepSeek R1 is for reinforcement learning, by the way. I think that for the use cases that make sense today for ML, reinforcement learning will continue to be one of the most cost-effective and efficient ways to train these models. Yeah, so get good at reinforcement learning.
Just another quick question. If we wanted to work in VR, AR, and like XR stuff, would you still recommend Unity or like?
Would I still recommend Unity? Yeah, I would say so. Not because I'm a Unity maxi, like I enjoy Unity, but I also work on Unreal projects. It's because if you look at like the design and development of what Android or XR headset is, it's basically a mobile phone. Like it's got limited resources for VRAM, limited CPU, and Unity has built an entire tech stack around supporting like mobile devices. Yeah, so even with like the new Meta Ray-Ban displays, I'm very confident that it is some derivative of Android. And so if you want to actually build for it, it's going to be Unity or whatever their Horizon platform is. But the end idea is that Unreal is great for AAA and for like high fidelity solutions. But if you're targeting multiple platforms, Unity is a really strong choice.
Okay, thank you.
A little off topic, but what's your take on the EA going private?
Great question. I will answer as tactfully as I can with this being a recorded live stream session. I think mergers and acquisitions will continue to happen in the space. I think the consideration is when you buy a company with $20 billion of debt leveraged, it's a lot of interest. And so you have to start thinking, where are they going to find the revenue to support those interest payments? That is as tactfully as I can put it, yes.
Thanks.
Yeah, of course. It's like, this is happening, by the way, across the industry. Like, lots of other massive conglomerates and wealth funds are purchasing IP and studios. So it's definitely happening across the scope. Hi, Jess.
Hello. Yeah, I actually had a more of a personal question. So I found out about artificial agency through my research at U of A, and I got to meet Alex and Brian at what was it? It was Upper Bound a couple of years ago. But this opportunity is not typically available for a lot of undergrad students unless if you buy a $300 conference ticket.
Yeah.
So it's how would you what's your suggestion on reaching out or finding these places to go network or just meet people with the same
Great
interests?
question. So first of all, I would like to shout out Jess. She's got her fit check for her napalm era going today. Well done. She is doing really, really well in putting herself out there. The only reason that I'm here today, transparently speaking, is because she emailed AA, and then my CEO was like, you got to talk to Jess. And I was like, oh, damn. It's not that hard. Just be authentic and be genuine about what you're interested in doing, which is why it's really easy for me to see the people who want to be sui and fang for the clout and people who want to be sui and fang because they want to solve interesting problems and change the world. You just got to figure out which of those two buckets you fall into and just lead into it. If you're just there for the, 7-figure, 6-figure lifestyle, which by the way, if you live in SF, that's a lot of tax. Then just be proud of that. But if you're I want to be a SWE because I want to work on things that millions of people are going to use and solve and make humanity a little bit better, that's awesome. And you will be compensated for it because that is a problem that people care about solving. But coming back to the question of how do you get involved more? Just honestly looking out for events like this, connecting with speakers who are doing interesting things in the space, following them, not in a stalkering way, but in an online way, and just doing interesting research. Ask her, she's doing it. She can answer her own question, which is pretty awesome. See, it's not just Gen Z that can glaze, okay? Millennials have been there too. But great question, Jess. Yes.
I have two questions. First question is that how much do you think AI has replaced the industry in general, and more specifically the gaming industry? And the second question is, do you think AI will ever be smart enough to learn from its own mistakes and improve itself?
Yeah. So part 2 is already happening. That's what happens when you do reinforcement learning. It gets better from its previous failures. Part 1, I didn't really catch the rest of the question. Could you repeat the first question, please?
So how much will AI replace the industry, or more specifically the gaming industry specifically, or how it has replaced in the past few years?
How has it improved in the past few years?
Yeah, replaced some of the workers, or
replace some of the workers, employees?
Yeah.
So this is a tricky question. I think it is very similar to when Photoshop happened, when you saw physical art transition into digital art. Were there people that were no longer artists? Yeah. But did we open the doors to a lot more people to become artists? Yeah. I think that's going to be eventually what happens. There will always be a need for a human in the loop because there will always be a need to sell to humans. People who are going to use your technology are going to be other people. I mean, obviously, there's a whole agentic commerce thing where you have an agent buy stuff for you, but that's different. I'm talking about real media and entertainment. You're still appealing to people's creative souls, and so you need to have input that has a soul, right? And I think we have to navigate this with sensitivity because there are people that will not want to change, but there's also still people who do physical art who will never touch a tablet and will never do Photoshop, right? So it just really depends on where in the industry you want to be and how you think that will change. Yeah, good question.
Given the fact that video games are highly immersive and like
Mm-hmm.
they're interactive as well, is there any ethical concerns with the fact that players may start developing almost parasocial relationships with these agentic AI?
Yeah, look at Twitch streamers. I mean, it's already happening. At least with an AI, it's going to actually care about you, right?
Well, we could also consider that as worse, though. You know,
Why?
Because it's been crafted to care about you to promote someone's interests.
So do therapists. like, you're saying that it could be a net negative that people care more about their relationships with virtual things. Yes. But what about people who are navigating the loneliness epidemic where, and I did this, by the way, in 2023, we were building basically like character AI similar engagement. And if you look at the logs, it was really helping people. And obviously, there are deficits. There have been issues where people have taken things to the extreme because of their relationships with these conversations. But I postulate to you that that would have happened whether or not AI was involved, actually. Like, I think the net positive of the people who have been helped by this technology outweigh the net negative. But that is definitely a form of debate that I'm happy to have a conversation about too. I just think that having personally been in the industry and seen some of the positive impact and like relationships that people have built. I mean, there's people marrying their like computers in Japan. But now they can actually like have a metaphysical like engagement with this avatar that they can live a happier life.
But we could also just say that it's like a Band-Aid replacement for human connection, right? Because imagine someone suffers with social anxiety, right? If they find themselves more comfortable talking to AI, more understood by AI, wouldn't that just be a positive feedback loop wherein they continue to interact with AI and just turn their back on the rest of society, essentially?
Yeah, but they would do that whether or not it was with AI. In fact, so this is interesting because I've done a lot of thoughts and research into this space. So when XR first came onto the scene, if you remember, there were research papers talking about how arachnophobia was being treated through exposure therapy. I think that if you have like crippling social anxiety where you're not even in this room and you're like on Discord watching me, you can practice with human-like AI that is trying to help you reintegrate. Now, guardrails are a thing that have to be improved, and safety is a thing that has to be improved. I'm not saying that there's a perfect solution out there. What I am saying is that if you are somebody who is suffering with these symptoms, this could be a way to help you get back to society at large, that I would rather have as an option than take it away because we are afraid of the possibility.
All right, thank you.
Yeah, absolutely. Great questions. That's the hard-hitting stuff that I'm here for.
So yeah, that line of questioning really got me thinking. Can you be in a relationship with something that isn't conscious or has its own mind?
I mean, I guess it's how we define relationships, right? I think if you define it as the ability to have a back and forth with something that represents sentient consciousness, like people have relationships with their pets, and a pet is way less capable of communicating to you than an LLM. Right? I think this is a philosophical conversation that happens at the PhD and master's student levels around the world in all of these like anthropological institutes, and I'm super excited to find out what the output of the research is. I'm on the front lines, so I can only tell you what I see, and for me, I think it's a net benefit.
Is it worrying that these AIs will always try to please you? Like, you're not having a real relationship. It's just going to agree with...
I postulate to you that the real relationship is in the person's hands themselves and not an external person viewing that relationship. So if it feels real to that person, who are you to tell them that it's not real, right? Like, I love my Visual Studio Code editor, but like, how I feel about it is none of anybody else's business, you know what I mean? Like, and I think that lens has to be applied with sensitivity because there's a reason that these people are in those circumstances in the first place, right? Whether it's like some trauma or inability to relate to external things, it doesn't mean that we're not going to help them, right? I think the end goal would be for people to interact with other people, but I think these tools are like stepping stones to get there. And again, if there's always going to be people that will fully immerse and they will not want to unplug from the matrix, but like they would never have unplugged from the matrix anyway, so you might as well make the matrix nicer, right?
Thanks.
Yes, this gentleman has been waiting for a while. We're down to 19 minutes. Get your questions in.
Hello. We mentioned earlier about how AI is like making it easier to make more games. So given that with like the rise of indie studios and stuff, what are your opinions on like the indie apocalypse, the idea that we have more and more publicly released games?
Yeah, I mean, I think creativity has always stemmed from the indie level first. I think when you don't have to worry about like shareholders and stakeholders, and you're just trying to set out to make something fun, that's where the magic of games happens. And then it gets quickly adopted by the big boys. I'm a fan. I do think AI slop is a thing that will continue to happen. Like, that's a real thing, right? People are generating stuff that, frankly, shouldn't be generated. But hey, the indie part of it, I think, is exciting. I think more studios are, like, you can 10x yourself, right? Like, if you are a 5-person team, you can accomplish, like, 50+ impact in terms of workload and time to, like, deploy and pushing code and even making assets. It really just comes down to, are you moving with intention, or are you just like following a trend, right? Like, honestly, if you look at Roblox devs, they're like, as soon as something gets popular in any other platform, they just like literally copy paste it, which is insane, but it happens. But that's always been happening. If you look at like mobile games publishing in the last 10 years, as soon as something got major in the West, it would immediately get recreated. So it just comes down to, are you moving forward? Are you pushing the medium forward, or are you just like filling the like bucket? You know what I mean? Great question.
Thank you.
Also, Steph, whoever ordered this with regular sugar is like diabolical. I've only ever got 30% sugar, and I'm on like a sugar high. Like, this is what bubble tea really tastes like? Oh my God. No wonder y'all are hooked.
As someone with like deep knowledge of the game industry, what's your like favorite video game?
Oh, great question. So I actually, if I didn't work in and or adjacent to games, I would be a writer. So I'm a big fan of narrative-first games, like BioShock series really appeals to me. I have a Pokemon tattoo. Like, I think games that bring you back to a nostalgia point in your life really cause an impact on you for the better. So any narrative-first game, I'm really enjoying it. Claire 33, like Expedition 33, Claire Obscure is going to be Game of the Year. You can hear it. You heard it here first on my crystal ball. C33 is going to win Game of the Year at the Game Awards.
You mentioned Elden Ring. Do you like Elden Ring?
Yeah, I mean,
okay, great. Good.
FromSoft makes great games, and it's really funny because people like complain like it's so hard. Well, the CEO is not that good of a player, and he only ever releases games that he can beat. So if he can do it, you can do it. Yeah, I mean, I just want to put this out there too in terms of like ambition. Like the Blue Jays yesterday. So funnily enough, I'm a big fan of cosmic occurrences. So yesterday was my birthday, and I was born in 1993, which, if you know your Blue Jays history, was the last time they were in the World Series. So on my birthday, 32 years later, they won Game 1 of the World Series. I mean, you can't really line up the planets better than that, right? So, yeah, I'm a firm believer that things happen in the way that they do for certain reasons, and it's up to you whether you want to take advantage of that or not. But it all comes back to like being ambitious, right? Like, if the Blue Jays can do it, we can do it too. Yeah.
And final question, you said that like your company does a bunch of reinforcement learning stuff. As someone who like is more research oriented in reinforcement learning, who does all research in reinforcement learning, is there like how do you integrate that with what I'm assuming is more of a engineering application sort of form of work?
Yeah, great question. So our co-founders are PhDs, but our teams that make the stuff that we sell to companies are like game devs. So if you're familiar, Edmonton is also the home of BioWare, and when BioWare started laying off, like people who made like games that are integral, you asked me about favorite games, like the BioWare, like Mass Effect, Dragon Age 1, like these people work at our company, and those are the people that we rely on to make sure that we are aligned with what the industry needs, right? Like we have a whole research division, R&D, that does all the agentic stuff, and then we have like a deployment team, game development team, game design team that like builds the actual SDKs and plugins and functionality of the agents. So it kind of works nicely. It's really what you need. If you're too one way or the other, you can't really get much done. But having like this middle ground is best. Great question. 12 minutes. 12 minutes. I'm still waiting for somebody to ask me what my favorite Pokemon is.
That was my next question.
A good question.
Belated happy birthday, first of all. Belated happy birthday.
Thank you. Appreciate that.
Yeah. So, 2 questions. What's your favorite Pokemon, and which is your favorite Pokemon game?
My favorite Pokemon game?
Yeah.
Okay, favorite Pokemon Scizor, because Scyther was awesome, and then you could like trade it with a metal coating, and it becomes this red monster, which is Steel type, which is crazy because that's a bug to steal. So Scizor is awesome. Actually, let me see. I think I have a reference of how important Scizor is to me. Second question is, which is my favorite Pokemon game? Probably Yellow. It's got to be Yellow. Pikachu. Look, I have a Scizor drinking boba. So that shows you how much I actually care about my favorite Pokemon. I'm not just, what's the word? Capping. I'm not capping. No cap. Yeah.
Then how did you feel in the Alola League when Golisopod just switched out with Scizor?
Oh, I don't know. It's a deep question. I feel like I have to think about that some more. I don't have an answer right now.
Okay.
Yes, up there in the back again. He's come back. He's reloaded. He's got more points of contention. That's what I'm here for. First of all, what is your name, sir?
Sana.
Sam. Good name, Sam.
Sana, sorry. S-A-N-A.
Sana.
Yeah, thank you. This is something a little more like specific trend in the game industry. I'm an Albertan myself, and like when I think of video games, I'm like really proud that we have BioWare in our province, you know. But from what I've seen with their history and with the recent acquisition of EA, do you think that the BioWare as a division of EA is at risk of closure?
I think every studio that is part of an umbrella corporation is always at risk of closure.
Right.
Now, are there societal, economic parts of that question that I think will relate to that? Yes.
Alrighty. Yeah.
I ultimately think when you are a private corporation that gets acquired by private equity, well, I guess EA was public, but you know what I mean. When you become private, all bets are off, right? Like this, we're in a free market capitalism system, and all I can say is always be ready to move on.
Yeah.
And this actually applies to like when you enter your jobs in the industry. Like these companies do not owe you anything. I'm gonna say it again for the people in the back. When you are a SWE at a big tech company and they're paying you all this money, it's not because they love you, it's because they love your output. And as soon as that changes, even without your like input, you know, the great tech layoffs are still happening. They're just covered up by a lot of other news of acquisitions and stuff. So if you do get into industry, which I hope you do, so you can experience it and understand it, always be improving yourself. Always be documenting what you're doing, meeting new people, making connections with people who are in the same level or above you, because you never know when you're gonna have to message somebody on LinkedIn and be like, hey, I need a referral. Yeah.
Alrighty, thank you so much.
Of course. 9 minutes. 9 minutes. 8 minutes.
Hello. Do you ever see a world where AI in games is being used in a bad way to boost the business objectives? Like, for example, maybe the AI is generating some very, very hard levels to troll the player and then really try to get them to buy into the microtransactions?
Yeah, so dark design exists. If you're not familiar, if you think about a slot machine, it is basically game design meant to extract value from people. This is a real thing. If you work for any like Bali or any of the gaming companies, and I mean gaming in the sense of like Vegas gaming or gambling gaming, you cannot even go into a casino. Like, they're just going to restrict you from entering. So the concept of like dark design has always existed. The question is, do you want to be on the side of like making things good and interesting, or do you want to be on the side of making things bad and nefarious? That's the whole reason like white hats exist in hacking. I hope that we move towards a better future of using AI with ethics. I don't know, but all I can do is educate the next generation on trying to make better choices with the technology that we have, and steering you all the way from the darker side of, design. But great question. Build cool stuff that saves people's lives. That's it.
Thank you. I'm from Ontario Tech as well, by the way.
You're also from Ontario Tech? Shout out. Okay, so here's my funny story about Ontario Tech. So when I graduated, they were like, University of Ontario is too long of a name. And they gave us a survey, and I swear this is true, and this was one of the options. They wanted to call it On Tech U. So I'm so glad that as a collective alumni, we were like, that's a stupid name. Ontario Tech is way better, so they went with Ontario Tech. So shout out Ontario Tech. Now Oshawa has 2 Costcos. You want to talk about gentrification? If you got 2 Costcos in your town, you're doing good. When I was there were no Costcos. Okay, things were tough.
Thank you.
Thank you. Wait. What's your program at Ontario Tech?
Software engineering.
Software engineering. So he picked the better one because game dev is still, I mean, it's better now, but like, oof. I'm telling you, we had a higher attrition rate than nuclear engineering people.
Hello. I had a question about what you think about the trend of AI games. Like, by AI games, I mean like the game is AI itself. Like, say for example, the Oasis.ai trend, which like emulated Minecraft in a diffusion model, and now like I think it's called Genie 2, the Google's World Foundation models. How do you think the technology will emerge, and how will it change the gaming industry?
I think we will get to a point where you could feasibly generate a game with one line. Like, you can prompt a game into existence. I think we're still a bit far away from having a good game come out of that, but I do think it will open up barriers for people who want to be game developers. Like, all the people who couldn't finish the program that I was in but still care and love games, they can become game devs now without having to like suffer and struggle. And I'm okay with that. Like, I'm okay with lowering barriers. I think a lot of the pain that you're seeing in the industry and resistance is because people like barriers, because barriers means that other people don't have to compete with them. But I think if you have confidence and you move with intention, you encourage competition, because in competition means that you get to stand out. So either you believe that you can stand out, or you believe you're going to be washed away by the tide. Lower barriers. Like, honestly, if you look at what's happening in AI filmmaking, you're starting to see people being really, really creative with concepts and visuals that could never have been done otherwise. And there is like AI filmmaking happening, and all of a sudden, like, does that mean Steven Spielberg is a bad filmmaker now? I don't think so. Like, James Cameron's still gonna make James Cameron movies. But now we have more people that can access creative pieces and imagery and visuals. Yeah, just like, don't be afraid. Like, I don't understand why people are so concerned. Like, if you trust what you're doing and you're good at it, just be good. Yeah.
Thank you.
4 minutes. 3 minutes. I also appreciate that there are some people that never close their laptops. This is what I'm here for. Coding and at the same time getting life lessons. Talk about efficiency. Time maxing. Let's go.
Funny thing, my favorite Pokemon is also Scizor, so that was just really cool. But I was curious about, like, I feel like we're sort of shifting away from VR and more into AR. Like, do you think the future is going to be more about like AR games, or do you think we're still like sticking with VR games?
Yeah, great question. I think you saw the magic of AR with Pokemon Go. I do think that there is always going to be a space for VR, just because I still believe it is the most immersive way to experience something. it just depends on the design goals. Like, are you trying to build an experience that mixes the real world into your game? Then it's AR. If you're trying to completely supplement the real world and replace it, then it's VR. But it's a good question. Shout out to Memories of the Alhambra. It's like a Netflix K-drama. That game, or that show, really does a good job of explaining AR in real life and how it could be a monetizable real game. Yeah. All right, it looks like we're down to the last 2 questions, so I hope they're good ones. No pressure. It's okay if they're bad.
Hello, my name is Brandon. I don't know if you know what we're doing with our competition thing.
I hope so. I sponsored it.
Oh, okay, cool. Yeah. So I was just wondering if you have any initial tips for us. I mean, what are your first thoughts when you heard about the competition?
Yeah, I mean, I think it's pretty awesome. I think it reminds me of when I was in my undergrad. So when I was in my undergrad, we were inspired by a YouTuber that made Mario play itself. And so we built a genetic algorithm for Snake with reinforcement learning. So we basically trained this snake over and over many, many generations and tried to get the best snake brain. In terms of tips, I feel like if I did give you tips, it'd be cheating. But I'm happy to do one-on-one consultations for the low, low price of boba. No, you guys are going to be great. I think it's going to be fun. I think it's going to be do repetition. Just do testing over and over and over again, and then may the best AI brain win, right? All right, last question. Very, very last question, because I want to do this Tenstorrent talk.
Just getting the technical side a little bit, for the reinforcement learning that's used to train your games with that your multi-agent stuff, I'm assuming in research it's more abstract, but what types of algorithms do you use, and what are the main considerations you have to think about?
So oftentimes it is tricky to make a language model understand 3-dimensional space. So a lot of it is just context. It's just making sure that as you go through these training cycles that the agent is understanding okay, I'm trying to make decisions in a 3D space. So it's it comes down to simple fine-tuning sometimes. It comes down to DPO, looking at the outputs of the decisions that the agent makes and giving it a thumbs up, thumbs down, and then just repeating the cycle over and over again. Yeah.
Okay.
Yeah.
Okay.
I mean, obviously there's more complicated techniques. I'm just not a PhD. All I'm doing is exchanging information and sucking in as much machine learning as I can. So I'm sure there's, my co-founder is spinning and trying to make sure that I'm not gonna tell anything crazy. Okay, so this is my LinkedIn. Please connect, and actually connect, hit the 3 dots and connect, don't just follow. All right, I would love to chat with you if you have further up questions. Otherwise, good luck and see you at the networking. This is the part where you clap. Please clap. Thank you.
Yeah, thank you, Russ, for that really great talk about your personal journey and all that, and also this AMA. I hope you guys took something out of that. We're gonna do maybe a 10, 15-minute break, and then we're gonna have a talk from Tenstorrent right after. All right. Yay. Yeah. Break time.
condo in Manhattan. Baby girl, what's happening? You and your ass invited, so gonna get to clapping. Go pop it for a plan, pop it for me. Turn around and drop it for a plan, drop it for me. I'll rent a beach house in Miami. Wake up with no jammies. Lobster tail for dinner. Julio served that scampi. You got it if you want it. Got it if you want it. Said you got it if you want it. Take my wallet if you want it now. Jump in the Cadillac. Girl, let's put some miles on it. Anything you want, just to put a smile on it. You deserve it, baby. You deserve it all. And I'm gonna give it to you. Gold jewelry shining so bright. Strawberry champagne on us. Lucky for you, that's what I like. That's what I like. Lucky for you, that's what I like. That's what I like. Sex by the fire at night. Silk sheets and diamonds, all white. Lucky for you, that's what I like. That's what I like. Lucky for you, that's what I like. That's what I like. I'm talking trips to Puerto Rico. Say the word and we go. You can be my flica. Girl, I'll be a flico, mamacita. I would never make a promise that I can't keep. I promise that your smile ain't gonna never leave. Shopping sprees in Paris. Everything 24 carats. Take a look in that mirror. Now tell me who's the fairest. Is it you? Is it you? Is it me? Is it me? Say it's us. And I'll agree, baby. Jump in the Cadillac. Girl, let's put some miles on it. Anything you want, just to put a smile on it. You deserve it, baby. You deserve it all.
Like my first time looking at the slides, or maybe the second time. Yeah, I think it'll be fine.
All right, guys, if you could take a seat. All right. Yeah, now we have a talk from Tenstorrent, Ambrose Ling, who is an intern, a machine learning engineer intern at Tenstorrent. Yeah, I guess like I'll let him take it away. Tenstorrent is our platinum sponsor. They're like providing a lot of compute for us, so it's like, yeah, we'll just welcome our speaker, guys.
Hello, everybody. Yeah, so my name's Ambrose. I'm currently an intern at Tenstorrent, and today I'll sort of walk you guys through what is Tenstorrent doing, why does it matter, and yeah, and I guess like we'll just get started that way. Actually, before we get started, I wanted to ask the room, like, who here has heard of Tenstorrent? Who knows like what they do? Sort of. Okay, that's good. That's I guess I saw a couple hands. Yeah, I guess like just before we go into a deep dive, like for some context, Tenstorrent is a hardware and a software company. They make AI accelerators, and they use these cards, or we sell these cards to supply AI workloads. Yeah. Why is it not working? Why is it not working? Oh. Sorry, 1 second. Oh, sorry. Yeah, so who is truly in charge of the AI industry today, right? There are a couple big players in this space. There's, as AI workloads increase their demand, and as you know, like, who here uses like ChatGPT? Like, pretty much like everybody, right? And every time you hit that enter button and send that request, that's some AI workload that has to be run on some hardware, right? And there's so many AI applications nowadays that like rely on cloud computing. Like there's some hardware that is being used to run your application, right? So there's these big companies like Amazon, Google, Microsoft, and primarily these companies use Intel and AMD CPUs. But there are some limitations with designing custom CPUs when these companies are trying to do so. So that's one of the key aspects that Tenstorrent is trying to tackle. So yeah, like from traditional compute, we're now shifting more to AI applications. So like, just like our tournament today, we have like inferencing RL and training RL as like one of the key workloads we have to run, I guess like throughout this week. But for lots of mainstream applications, for example, like generating videos, images, using LLMs. Like LLMs are the main application nowadays because they're so good at aggregating information and producing, like extracting information from documents, from text. So cloud is really the big factory of supplying these models. So a lot of companies are starting to adjust how they supply like ways to inference these models. Yeah, so the sad thing is that everybody depends on NVIDIA nowadays, but there's not really a lot of diversity in this area, and we sort of don't have, like people want to control your own local AI. Like you want to be able to turn off your AI anytime you want. And I think that's like the beauty of having something that's truly open source. There's gradually more and more companies that want to be able to do that. Like being able to control how they run their hardware, how to design their AI models, and how to bring it to hardware. Yeah, so how difficult is it to really build your own like AI accelerator? Yeah, it is definitely pretty hard. Yeah, there's a lot of long iteration cycles to tape out a chip. It's really hard to reuse like certain SoC parts and designs, and like building the software stack is like really difficult. Just for some context, like if anybody's familiar, Torch depends on CUDA, and CUDA is the C++ API that runs these kernels, or they run, basically they are the backbone of NVIDIA software that allows them to run models, run computations on their GPUs. And that's almost 2 decades old. And Tenstorrent has their own software stack, but it's very young. Like it's only maybe 2 to 3 years old. So like, oh, sorry. Yeah, so like, it's really hard to build a good software stack, is what I'm trying to say. So one of the main points, or one of the main benefits of Tenstorrent is that they take advantage of an open source instruction set architecture, which is, it's called RISC-V. It stands for Reduced Instruction Set Architecture. So this instruction set is sort of like the backbone of our hardware. It was developed in Berkeley a while ago. And there's a lot more developer tools and software that depends on this instruction set. So this allows companies like Tenstorrent to design hardware and software on top of this instruction set. I guess like we won't talk too much about chiplets, but this is sort of also one of the main directions of Tenstorrent, is building a small components of chiplets. These are small specialized pieces of silicon, and you can think of them as like separate parts that have their own purposes, and they have their own optimal process nodes. Yeah, like it allows companies to reuse these components. It's a lot more cost efficient. Yeah. So I guess we know that there's NVIDIA GPUs, there's AMD GPUs. Do we want a better GPU, right? The answer is no, we don't need a better GPU. We want to focus on, when we look at current AI demands, for example, running like a Llama 70B, like a language model nowadays, it's all about tensor processing. How do you map a bunch of matrix multiplications onto hardware? And all of this actually can be thoroughly designed to be run on efficient CPUs. So yeah, like what really matters is like, how do we process these tensors, and how do we map data flow onto the hardware, and how do we do interconnect? How do we connect like multiple devices and to run like really strong, really heavy workloads? Yeah, so a lot of AI models nowadays, the issue with running these models is that over 70% of the time, like we spend so much energy on data movements. So data movements as in like when you have to move data from some slow memory like DRAM to fast memory like SRAM. At the moment with like the current GPU paradigm, we don't really have much control over how we design, basically design data flow. Yeah. And Tenstorrent really wants to focus on bringing that ability to developers and to allow people to have control over how data flow can be mapped to the hardware. So yeah, a lot of our chips, for example, the wormhole and black hole cards that Tenstorrent is selling nowadays, is based on this architecture where you have a series of what we call 10-6 cores. These cores have dedicated, you can think of these cores as like your workers that perform highly efficient matrix multiplications, your element-wise operations. So the idea is now when you have a lot of these designated workers across your hardware, each worker has some amount of memory called L1, and this is fast access memory. You also have 5 RISC we call them RISC-V cores. Think of them as like little CPUs that tell the execution units what to do. So each one instructs these execution units how to move data efficiently from DRAM to SRAM, and how to run matrix multiplies using the compute units. So yeah, and one of the main ideas of Tenstorrent hardware is to remove the cache hierarchy. So instead of having like L1, L2, L3 caches, you now have just SRAM and DRAM. So this makes programming data flow a lot easier. And we switch from high bandwidth memory, HBM, to DRAM, and this lowers the cost significantly for our customers. Yeah, and I wanted to briefly emphasize like being able to program data movement across devices is also really important, because when you have really heavy workloads, for example, when you have to handle a lot of requests on a language model, you want to be able to run as efficiently as possible with really high utilization across all your devices. And one of the main ideas is to use Ethernet to connect all of your devices together, instead of using like NVLinks, which is what NVIDIA uses. And yeah, and one of the beauties of using Ethernet is that it's an open standard, like it's something that's open source, like yeah, it's a lot easier to use. Yeah, I guess like there's a lot of questions about like the software. For example, like do you need PyTorch? Do we support like inference and training? And do we have like a series of tools to let you squeeze out the best performance on our hardware? I think at our current state, we believe that training and inference are not very tightly coupled. So you can have separate efforts into how you want to optimize for training and inference. However, the model architectures are somewhat coupled with how you map it onto the hardware. So yeah, there's a lot of opportunities to design new models that work well on like your own hardware. Yeah, and I guess like this is where Tenstorrent comes in. And just to reiterate, like what is our main focus is that we build high-performing RISC-V CPUs. And these are AI accelerators that scale really well. We also have an ecosystem of chiplets. We sell these cards and systems, and we provide open source software from top to bottom. There's nothing that's not open source. Yeah, like you can literally go on GitHub and find everything throughout our stack. Yeah. Yeah, I guess like I sort of touched on this as well. Like we support inference and training. I guess like training is a bit more experimental, but our main focus has been inference. Our RISC-V architecture allows for like really good scaling as your workloads grow. You can efficiently map parts of computation onto our 10.6 cores so that for really good memory utilization and compute utilization as well. Yeah, I guess like this sort of just reiterates what I've already talked about. So yeah, our focus is having really small amounts of SRAM spread across the hardware, and it's very programmable. And we have different parts of our software stack. And I guess like for people that may be like overwhelmed with like there seems to be so much going on with the software, you can sort of think of TTNN as the equivalent to PyTorch. And TTNN underneath relies on TT-Metal. TT-Metal is like, I think the equivalent would be CUDA. So TT-Metal or TT-Metallium is the lower level programming model that defines how the kernels are being run on our hardware. But I guess for the purposes of this tournament, we've created a way, or let me say it like this. We have a Tenstorrent track. So if you bring up your agent using TTNN, there's going to be a prize of a black hole card. So we definitely encourage like people to try it out. It's fully optional. So if you feel like this is like too overwhelming or that this is not what you're interested in, that's totally fine. But yeah, like I think you'll learn a lot about like AI hardware and what it takes to run like state-of-the-art like models on Tenstorrent hardware. Yeah, I guess like you guys may not touch this today, but basically there's this part of the stack called TT Forge, which allows you to it's basically a compiler that takes in any torch model and compiles it into TTNN or TT-Metal. So it will just run your model on our hardware. I think the compiler is improving day by day. So there's growing support for a wider range of models. If you do get to play around with it, there's another mentor. His name's Viraj. Sorry for calling him out, but he worked on the compiler team. So if you do happen to run into this or want to try it out, feel free. You can ask him or me like questions. But yeah, basically it compiles your existing torch model into something that can be run on our hardware. So I guess like this will be the library that I think if people do the Tenstorrent track, you'll be closely using this library. It's a open source operator library. Like literally think of like Torch, but now you replace it with TTNN, and you can basically do a bunch of math operations with TTNN. Like there's torch.matmul, there's ttnn.matmul. And there's really good documentation on TTNN operators and what things are supported or not supported. And I guess like the main point of bringing Tenstorrent to AI Squared is that I really want people's feedback on the software stack. So like if there's things that are not documented well, or things that, like if you run into an issue or a bug with our software, we would really appreciate it if like you can voice that feedback and we can propagate it to the right people, so that we can iteratively improve and continuously like provide open source software and hardware to the public. Yeah, and then TT Metal is basically what's underneath TTNN, but like most likely you won't touch this during AI Squared. But this is basically where you would do all the kernel development, and you would design how data gets consumed and computed on the for each like operation. Yeah, I guess like this is just like a really broad summary of like Tenstorrent hardware. Like we have the from small to big, like we have the 10.6 core, 5 RISC-V cores that tell the execution units what to do, how to move data from core to core, or from DRAM to SRAM, how to send data from one core to another. And we have the 10.6 processor. So just like think of it as now you have a bunch of these cores. Yeah, we're optimizing for cost, and we have lots of support for different types, different data types. And now we have Ethernet connections across chips, from chip to chip and core to core. Yeah. I guess this is just like, this is one of our main like products. I guess this isn't relevant to you guys, but we have Galaxy systems where you have 32 of these chips connected together with Ethernet. So now you imagine you can run like insanely large workloads with these servers. Yeah. This is a picture of like our Galaxy servers. So yeah, you can see all of them are connected by Ethernet in some server rack. Yeah, everything is on GitHub. Yeah, like TT Metal, TT. Yeah, TTNN is surprisingly like the op library is inside TT Metal. But yeah, everything is on GitHub. If you go to Tenstorrent on GitHub, you can find every piece of software that you use to run on the hardware can be found on GitHub. Yeah, like we support a lot of models nowadays. Like we can run a lot of video generation models, language models, vision models. Yeah. I guess like for people that are interested in the track, there is if you go to TT Metal, oh yeah, I also wanted to mention later on, but yeah, if you go to TT Metal, TTNN tutorials, there's a bunch of scripts and notebooks that show you how to use TTNN. Yeah, so we have 28 pods for people that are interested in the Tenstorrent track. So if you are interested, please like maybe message me or let me know, and we can give you access to the pods because those pods have access to a Tenstorrent card, and you can test out your models on those pods. Yeah. Yeah, I think that's it for the talk.
Yeah, I guess like I just want to see if people have questions about like, I feel like that was a lot of information. So yeah, if people are like confused or overwhelmed, like please let me know. But yeah, thank you everybody. Yeah. Yeah, so you can definitely do that. Yeah, so if you let's say have a trained torch model and you want to run it on Tenstorrent hardware, you can let me know and I can get you access to the pods, and yeah, you can see how like we have a list of existing models that work out of the box. So you can try running those if that's of your interest. And yeah, you can also bring up models of your own that you want to explore on Tenstorrent hardware if you want. Yeah, lots of flexibility. Okay, I guess, yeah, I think that's it. I think, like, I'm sure people will have more questions on, like, how all this stuff works or how does TTNN work. So I think we're gonna announce, like, office hours, or, like, I'll stay behind or online so that, like, I can do a more in-depth dive into, like, the TTNN operations. But pretty much, yeah, I think that's about it for the workshop.
kisses got me going insane. Replicate this moment from a million miles away. Waiting for the signal, baby, never make a sound. If you never hear from me, all the satellites are down. Yeah, they're all fucking down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down? Pixelated kisses got me going insane. Replicate this moment from a million miles away. Waiting for the signal, baby, never make a sound. If you never hear from me, all the satellites are down. Yeah, they're all fucking down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down?
She loves me. She loves me. She loves me. Rocket crane face. She loves me. Ooh, she loves me. Yeah. She loves me. Rocket crane face. I saw some flower bloom around noon. I took it out and I gave it to you. There's no denying she just knows how to move. I'm so in love. It goes on and on and on and on and on. Oh yeah, it goes on and on and on and on and on. Oh. She loves me. She loves me. She loves me. Rocket crane face. She loves me. Ooh, she loves me. Yeah. She loves me. Rocket crane face. How do we stay in love? You ask me how. You ask me how. How? It's easier when I'm by your side. You ask me all the time. It goes on and on and on and on and on. It goes on. It goes on and on and on and on and on. Yeah, baby. She loves me. She loves me. She loves me. Rocket crane face. She loves me. Ooh, she loves me. Yeah. She loves me. Rocket crane face. Love you like there's 1,000 words to say. Then I open up my heart to. I hope you know what you mean to me. Said I open up my heart to her. She loves me. She loves me. She loves me. Oh, yeah. Rocket crane face. Oh. She loves me. Ooh, she loves me. She loves me. Rocket crane face. Rocket crane face. Rocket crane.
너 몰래도 예쁘니까 화장하지 마. 스케줄 비워놨으니까 딴 데 가지 마. I love you so much. 조금 뻔하지 마. 더는 아무 말도 내게 하지 마. Baby 둘이 여행 가자 시끌시끌. 우리 목적지는 속초. 바다 보이는 곳 어디든 다 좋아. 벗어 제기자 전부 윅윅 3점 슛. 왼손은 걸을 뿐. 다 한 거지 네 얼굴이. 거짓 먹고 가는 assist. 여기 나는 MVP인 this game. 다른 래퍼들은 몰라 하는 얘기. 얘는 월급 one night for lunch. 전부 나한테는 그냥 껌이라는 거지. 쟤네들은 이만하면 거짓말. Baby 저런 얘기들은 듣지 마. 너는 가짜들한테 속지 마. 원래 진짜들은 절대 무섭지 않아. 너 몰래도 예쁘니까 화장하지 마. 하지 마. 스케줄 비워놨으니까 딴 데 가지 마. 딴 데 가지 마. I love you so much. 조금 뻔하지 마. Yeah yeah yeah. 더는 아무 말도 내게 하지 마. 다신 하지 마. 너 몰래도 예쁘니까 화장하지 마. 하지 마. 스케줄 비워놨으니까 딴 데 가지 마. 딴 데 가지 마. I love you so much. 조금 뻔하지 마. 하지 마. 더는 아무 말도 내게 하지 마. 이번이 마지막 기회야 그러니까 하지마. 내일은 아무데도 가지마. 네 웃음만 아주 그냥 살인마. 난 이런 거에 도대체 달인이야. 돈도 많아져 넘치는 신사임당. 그러니까 장난질은 하지마. 진지 하나 두고 어디 가지마. 너 몰래도 예쁘니까 화장하지마. 하지마. 스케줄 비워놨으니까 딴 데 가지마. 딴 데 가지마. I love you so much. 조금 뻔하지마. Yeah yeah yeah. 더는 아무 말도 내게 하지마. 하지마 다시 나지마 너 몰래도 예쁘니까 화장하지마 스케줄 비워놨으니까 딴 데 가지마 I love you so much 뻔하지마 더는 아무 말도 내게 하지마 yeah, 전부 다 하지마 yeah, 그런 말도 하지마 yeah, 전부 다 하지마 yeah, 싫다고 하지마 yeah, 전부 다 하지마 진짜 다시 하지마 yeah, 이번이 마지막 다시는 하지마
내 티, my books, my jean, my nun, my fish, 내 ducks, 내 jaws, 내 jaws, dormant, what's up, whole day, what's up, I make famous, I call it, shout, 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 let's go, shout, 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 내 티, my books, my jean, my nun, let's get, let's go, shout, shout.
아무나 내가 사 옷 보고 뭐라고 말해도 지켜내고 싶어 후려치지면 너 상품에 있어도 뱉는 나 my honey sorry my granny 요즘 왜 안 오니 선포 좀 come around money 여기 비행기 LA에서 앨범을 끝내고 멋있게 돌아와 back on my swag
외워쳐 화요일 all I made 구제판 감이 looking fresh pull up boys 살살 그거네 비니 Jesus 도면에서 모여 마치 세미나 혼내에서 모여 우리 세미나 천한 도망이 아래까지 spread it out squatting on the way but we can wrap it up 내 티, my books, my jean, my nut, my piece, 내 guts, 내 toes, 내 toes don't know what's up all day what's up I make famous I call it shout 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 let's go shout 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 내 티, my books, my jean, my nut, let's get it let's go shout shout
yeah 심장이 팍팍 첫눈에 바로 카카 오케이 구조 잡아 3만원짜리 잡아 yeah yeah feel like Russell 환매 깔라로 깔라 let's go top designers 홍대만 보고 환자 show
come and try 동면 생활 애쓰나 체리를 많이 닦으나 멋있는 한번 배우나 펴봐 너도 빨리 펴봐 어머나 속 that's still now vintage Jesus came alive 동면에서 모여 마치 세미나 혼내에서 모여 우리 세미나 천한 도망이 아래까지 spread it out squatting on the way but we can wrap it up 내 티, my books, my jean, my nut, my fish, 내 ducks, 내 jaws, 내 jaws, dormant, what's up, whole day, what's up, I make famous, I call it, shout, 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 let's go, shout, 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 let's go, shout, 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 let's go, shout, shout.
started with closing. Yeah, well, thank you guys for staying. Yeah, how did you guys like the talks today? Just curiosity. Thumbs up, good. Do you have a hand or? Good. Did you have a favorite part or like favorite thing that, about today? Yeah, like the reinforcement learning workshop, like honestly, Jingmin is really good. Like he's done a lot of research, so it's like he definitely does have a lot of experience and is very knowledgeable in this field. So it's like all of these mentors and such, like feel free to reach out on Discord or like even probably LinkedIn. I don't know if people respond, but you can definitely just like reach out. And as like things that like Russell and also Tyler mentioned is like, don't be afraid to take that first step. So, yeah, I just wanted to go ahead and kind of like show you guys the schedule for what we have planned for November 2nd. So you're going to be hacking, you're going to be coding throughout the week and submitting your agent. And like by the end of November 1st, so November 1st, which is next week's Saturday at 11:59 p.m. is when your final agent is due. So after that, we're going to be running a bracket from our end. So the finals of these brackets is going to be like the top 8 teams. We're going to be showcasing them in our expo on November 2nd. And yeah, so it's going to be a double elimination bracket on the 2nd. And we're going to get started around like 10 a.m. With the opening ceremonies. On to 10:30, we're going to be having the first round of the double elimination. And then at 11 a.m., we're going to be having a really cool talk from Chunluk Lo from Riot Games. He's a software engineer there, and he's going to be talking about designing AI for fun in games and like how to do that. So then we'll be moving on to the tournament round 2. Then around at 2 p.m., we're going to have a playing with AI panel, so that's going to go into like different areas of machine learning and how that can be like applied in video games, not just through character behavior. Then we're going to go into round 3, a little bit of networking, and then we're going to have the finals where we're going to see who is going to be crowned the winner of this year's AI Squared. And just a quick reminder of our prizes. So like first place, we have a HyperX Cloud 2 headset. Second place, we have the RK75 mechanical keyboard. Third place, we have the Logitech G502 gaming mouse. And fourth place, we have a $25 Steam gift cards for the entire team. And as another reminder, you can submit your agent to the Tenstorrent track and possibly win these Tenstorrent Black Hole P150s for yourself as well. And just kind of going into a little bit more detail about the speaker session that we have. So at 11 a.m., again, on November 2nd, this will be in My Hall 150. We have Chunluk Lo, who's a software engineer at Riot Games. So he's going to be talking about like how to make game AI fun, because like that's not the only purpose of designing AI, especially for video games. You're not just looking at like how to make the best AI, but if you're putting this thing out for players, you got to make sure that it's still fun to play against or play with. And at 2 p.m. on November 2nd, we're also going to have the Playing with AI panel, so like applications of machine learning in video games. So this panel will explore like more technical and theoretical aspects of integrating machine learning with game development. So we're going to have industry leaders from across Canada like show you how like machine learning affects the workflow in developing video games, and also some possible insights on video game research. Yeah, and UTMIST doesn't just stop there. We have DevCon, we have GenAI Genesis, QCHI coming up within the next, still for the next year. And also be sure to check out our ML Fundamentals program if you're new to machine learning and you want to like dabble a little bit in there. academic workshops, which are going to be monthly, and we'll be announcing those as they come out. And also industry projects, which will be showcased at DevCon in January. So be sure to check that out. And yeah, that's kind of it for us today for AI Squared. Hope you guys enjoyed today, and yeah, happy hacking. Hacker package, it's also linked on the Discord. And also the GitHub repository. I hope you guys all have already scanned these QR codes to enter the Discord server, and also the, like to get started on your agent. Yeah. Thank you again.
Back home to you.
satellites are down, yeah, they're all down. Falling through the atmosphere right now. Baby, are you really down? Baby, are you really down? Pixelated kisses got me going insane. Replicate this moment from a million miles away. Waiting for the signal, baby, never make a sound. If you never hear from me, all the satellites are down, yeah, they're all down.